to share it today. As Olga mentioned, as you can see, the title of this hands-on session is Introduction to R for Beginners. So like Olga mentioned, we're going to try to take it slow, take it step by step. And please, by all means, ask questions as they come up if some material doesn't make sense or you'd like to get additional clarification. Please don't hesitate to reach out to questions. Before I get into it, I just want to make sure I point everybody to, let me come out of here, my window here. If you come to the May Institute website here, I'm sure you've gone there before. If you come to the documentation, take a look here on the May 7th and May 8th documents, May 7 in particular. If you click on the documents here, we have some introductory information here. And what's going to be important here is that you have a working version of R and RStudio working, because we're actually going to be typing code and doing some exercises. So in this document, if you scroll down, we have this pre-workshop setup. There are two options that you have. One is you can install R and RStudio on your own computer. And you can follow these instructions here. But basically, you first, number one, you install R. You need to do that first. Then you install the free open source version of the RStudio desktop application. After you do that, there's a particular package that we're going to need. It's called the tidyverse package. There's just some basic instructions. You're going to do that from RStudio to do that. And once you have that, you'll have a working, hopefully, fingers crossed, a working RStudio environment. Hopefully you can reach out to the TAs if there's any sort of technical problems. That can be kind of tricky. There's another option where you don't need to do as much setup here, and that is to use Rstudio Cloud here. I've set up a cloud-based environment that has all of our materials and exercises and data there. The only thing you need to do is first create a free Rstudio Cloud account. Once you do that, then you can go to this link here. And if you do that, let me just show you here. If you go to this link here, it will take you to a new window, in which case you will have a window that looks like this, and exercises is the name of the project that we're going to be doing. If you click on that, give it a few seconds. These are cloud resources. It's sort of getting machines ready for you to work. It usually takes, maybe 10, 15, 20 seconds here. And when this is done with resuming the project, you will have a working RStudio environment all ready to go with the data and scripts there that we're going to be working on. And you don't have to do any setup. Okay, it looks like it's just coming up here. Okay, great. And we're going to talk about how to use RStudio, so don't worry about that. But if you do not yet have a working version of R and RStudio on your computer, probably using this Rstudio Cloud option is probably the quickest way to go and get set up. So as I'm kind of going through the intro materials and you don't have a working RStudio, please go ahead and go through this and get that set up so you have something to work from. Any questions have popped up?
Yeah, there's already one question.
Yeah, okay, great.
Can I download R to my computer and also use Rcloud at the same time?
Yes, you can. And essentially, Rstudio Cloud is going to be available as part of this workshop. And I've made the special project for the workshop. After that, you have, I think, 15 free hours of the Rstudio Cloud per month that you can use on their free plan. And so just note that there are some time limits that will happen on Rstudio Cloud after the workshop is over, but feel free to use both. And in fact, I encourage both. It's nice to get experience with using both. Okay, great. Okay, let's go back to our material here. All right, so first, let me give a quick overview of what we're going to try to accomplish here. As I said, this is intended to be a workshop to get people started who are either completely new to R encoding or are just getting started out, to get familiar, get comfortable with executing code, running code, learning some essentials of R syntax, and start working with tabular data frames. So we're going to cover those topics here today. Then tomorrow, we're going to do a little bit of a transition. We're going to take the material that we learned today. We're going to transition to learning about this idea of tidy data. This is a really important concept, I would say, in data analysis in general, but in R, it's really a key piece of sort of modern R, if you will, how you work with data here. We're going to learn about a really cool set of packages called the tidyverse. And in particular, we're going to see a particular package called dplyr that allows you to do some really cool data manipulation using syntax that I think is really human readable, understandable, hopefully not too difficult to write, but allows you to do some fairly complex data manipulations and operations in a short amount of code. So we'll have some neat examples of that tomorrow as well. Okay, so here's a really high-level overview of what I'd like to cover. And hopefully you can accomplish all these tasks by the time we're done with the workshop tomorrow. So first of all, we're going to start with using Rstudio. That's the place where you're going to type and execute code. In my daily job, I live in Rstudio pretty much all day when I'm not in meetings. I'm writing and executing code in Rstudio. I'm generating data reports. I sometimes make web-based applications through Rstudio. It's really just a key, wonderful piece of the sort of our tool chain, and it's really important to know how to use. Once we're comfortable writing and executing code, we're then going to talk about the fundamental syntax of R that allows us to actually start doing some work with data. We're not going to cover the entire R language and syntax. That's too much to cover in a short intro course, but we're going to cover, I think, what I think are the main pieces that can get you going. We're going to take a quick little detour, and we'll talk about how we can get data into R. Obviously, you're not going to want to type all of your data into R in order to analyze it. You're probably going to have to get it into R somehow. We'll talk about how you can fairly easily read formatted text files into R like CSV files. And then we're going to start working with those data tables. And then tomorrow, like I said, we're going to talk about this idea of tidy data and doing some more interesting things on data tables. Okay, so at the end, hopefully you'll be able to, for example, read a data file into R and do some basic data manipulation and analysis with it. That's going to be our main goal. Olga mentioned here, but I just want to reiterate a big thanks to our TAs. It takes a lot of time on busy schedules to help out for things like this, and certainly really appreciate their help here to help us out with this workshop. Okay, now we're going to transition into a little intro here. I just want to motivate what we're doing. R, as you can see from the title here, I think it's a really great language for data analysis. And
just point out that you
yes.
are the host now, so you can use the polling feature.
I am the poll. You know, let's try that, Olga. I would love to do that. Do I need to stop? Oh no, I see the polls right here. Would you mind? Okay, there's one poll here. I'm just curious. I'm going to start a poll here that's going to ask you how familiar you are with R. That's a lot of R's. Let's give this a shot. If you don't mind.
So please don't be shy. You should have a poll on the screen now if you don't mind answering. And all the answers are anonymous. We will not know who you are, but if you don't mind giving your answer, and then we will see the result in the end. Okay,
great. We're about 90% answered. This is great. That's a good response rate here for a survey. Okay, that's pretty good. Let's end the poll here, and I think okay. Let me share the results here. Great. Can you see the results coming through?
Yes, we can.
Yep. Great. Okay. Yeah. Okay. Great. So I think what I expected. So lots of, not quite half, almost half never have used it, and a few are beginners. We have some people that have written quite a few lines of code. That's great. If there's any, sort of input or additional context you'd like to add in your experience, certainly welcome to do that, and maybe post that in the Q&A, and we can highlight those ideas as well as they come through. Okay, let me get rid of that. Let me do this. Great. Okay. So, so back to the idea about why R. There's lots of programming languages, and oftentimes when I teach these workshops, the inevitable question comes up, why not Python? I hear Python's better, faster, who knows, whatever, nice term you want to put there. And I think Python is a great language. In fact, I use Python a lot too. R is my main language I use in my day-to-day analysis, but there are other tools as well. I see R as a tool to get work done, and I think R is a really great tool, particularly for data analysis. And just as a note, languages like C and Java and Python, these are more general purpose programming languages. A software developer, for example, would learn these languages and use them perhaps at any kind of industry, financial industry, business, sales, whatever, to write software and write applications, for example, that people use on a daily basis. R is not really that kind of language. It is a full-featured programming language, but it's typically not used to make like an enterprise, business accounting software application, for example. What it is great, though, is working with data. R was developed from the very beginning to be a data-first language. And because of that, I think it's a really great choice for people like us. We're scientists. We deal with data every day. And so R has really been designed and continues to be developed with that in mind. And that's why it makes it a really great language for doing data analysis. So the question, I don't think, is really R versus Python. I think it's partially about what you like to use and maybe what fits with you better. And I'd like to say that I think R is just a great choice to learn. So. And hopefully, maybe you also agree as well, because you've come to this workshop. And I hope that's the case, and hopefully we can walk through more of those reasons through this workshop. Okay, a little bit about the R learning curve. If we go back, say, 10 years ago, let me admit, R can be a little bit of a quirky language, and it can be difficult to difficult to start learning, getting comfortable with it, particularly in the very beginning phase. And 10 years ago, that was, I think, particularly so. R was not as popular. There weren't as many resources. There wasn't as large of a community, and getting started was kind of difficult. And there were some posting boards where you could go to with questions, but sometimes those boards were maybe not quite so friendly for beginners. And I think the environment was just less set up to help people new to R really get into it and learn it. That has changed immensely, particularly in the last 5 years or so. R is much more mature today. It's grown a lot. Believe it or not, R just celebrated its 20th anniversary last year since version 1.0. So even though people tend to hear more about it more recently, it's actually been around for 20 years. So it's quite mature at this point. It continues to get developed, and more things are being added to it. And I think what's really cool about R is that it has an amazing community that has developed around it that's extremely friendly to beginners and new users. It didn't used to be the case, but now it really is. And so I think it's really a great environment in which to learn the language. And I'll talk about some resources, I guess, tomorrow at the end of the course, where you can go to continue learning, ask questions in a friendly environment, and so on. It's also interesting to note that sometimes you look at rankings of computer languages. Usually those have languages like Python and C and Java. But interestingly, R has sort of been becoming a top language, has been popping up into these top 10 lists. It kind of moves around from year to year. But it's really interesting that a really data sort of centric language is becoming really quite popular. So, it is still challenging to learn. So let me, just to set expectations, we're going to hopefully help you get on your way to learning R, but you're not going to become an expert, overnight. It does take time to learn R. When I first started learning R, I really, I knew how to program, but I really had to buckle down in the beginning and really sort of work with the code and practice and so on. It just takes time. So let me just put that out there. It is going to take time. Maybe all of these concepts and ideas won't necessarily make sense, and it will be frustrating, but that's just part of the learning process. And please, I would really highly recommend stick through it. I think even if you don't do data analysis on a daily basis, I think it's a really cool, important tool to have, even for just doing some basic work. And I think the time you invest will really be worth it in the end. So please stick with it. I think it will be a really useful tool. We're not going to cover all of these ideas, but I just wanted to give a survey of the R ecosystem here. It's more than just the programming language. Okay, so we're going to be talking mainly about the R programming language today, but there's also a lot of other additional things. So for example, there are R packages. These are sort of additional libraries that you can download into R that give you additional functionality. We're going to be talking about one of those packages, dplyr, tomorrow, which is really cool. This in the middle here, this sticker here, ggplot2. Probably if you have some kind of knowledge of R, you might know about ggplot2. Some people will learn R very specifically just so they can use this package. It's used for data visualization, and it's a really amazing package for data visualization. It's influenced other data visualization packages in other languages, and it's really amazing, powerful, and flexible. We're not going to cover that, but this is one of those must-learn kind of packages in R, and lots of resources online about where to learn about ggplot2. We also have Rstudio, the application, which I'm going to talk about, and we're going to start using. If you're interested in writing data web applications, the R ecosystem has a framework known as Shiny that allows you in R code to write interactive data applications. I don't do this too much, but every so often there are projects that come along that really require some interactive apps, and it's really nice to be able in R code to fairly quickly get some really cool web apps that you can say deploy out to your company or out to your lab or whatever, to help people look at and interact with data. There's also whole another ecosystem around R Markdown. This is a infrastructure that allows you to make things like reproducible reports, and this R Markdown system has also been modified to allow you to make blogs and even books. So if you wanted to write a book about something, you can use R to do that, and it's really cool. So like I said, we're not going to cover even most of these things here, but just want to note that there's a lot of stuff. Once you learn R, you have almost an infinite amount of possibilities to go to from there. Okay, a little bit of logistics here before we get into the main materials here. The main lectures are going to occur here in this main Zoom room. Throughout the lectures, we're going to take, say, 5 minutes here and there to do little exercises. This is where I'm going to ask you to jump into your Rstudio or Rstudio Cloud session. We'll be typing code. We'll be doing some exercises just to practice things. These are meant to be little bite-sized chunks, not hopefully too difficult or take too long to get through, but I just want you to be able to practice things. So that will all happen here in the main Zoom room. We do have our TAs here that are available to ask and answer questions as we go through things. If you get really lost, the TAs will be able to create separate Zoom rooms for people to break out to if we need to. Hopefully we won't have to do that, but it is available if you need it. Course materials are located at this link here at the Northeastern website. I'm also referencing them all on GitHub. Let me just go there and show you what this looks like. If you go to the GitHub site here, I don't know if you've used GitHub before. Let me zoom in a little bit, but all the materials are here. So for example, the lecture slides are linked here. You can download those as PDFs here. Let me go back here. There's some data for some exercises that we're going to be talking about at the end. You don't need those immediately right now, but you definitely do want the data here. So if you haven't downloaded the zip file, please click on the file and you can download it here. Make sure you have that available. We're going to be using some of that data. So anyways, just want to let you know that the GitHub material is here and it will live here, so you can access that after the course as well. Okay, let me go back to my slides here. Let's see, any questions have come up about logistics? Okay. Like I said, if you don't have a working version of Rstudio, please get that working, because we're going to start using that here pretty soon. And the easiest and quickest way, as I mentioned, is to use the Rstudio Cloud option if you don't have a working session right now. Okay, great. Let me go back here. Okay, I have my slides up. Let me get rid of that one. Let's go to part 2. Excuse me. Okay. All right. So we're going to be, actually, sorry, let me go to my PowerPoints. Too many folders here. Okay. All right. So step 1, we need to, before we start working with R, we need to be able to type R code. We need to be able to execute R code. And that's what we're going to be using Rstudio for. So this is the topic of this particular module. So what we're going to do is we're going to learn about what Rstudio is and why it's important. We're going to learn how to type and execute R code. And then we're also going to learn about this idea of RStudio projects. This won't be a main topic or a main thing for us in this workshop, but this is going to be important for when you go off after the workshop to start doing your own work. I'm going to highly suggest that you use this organizational structure known as an RStudio project. And I'll show you how to make and interact with those. Okay.
Ryan, there's a question.
Yes, please.
Could you remind everyone where we can find the lecture slides that we're looking at right now?
Yes, exactly. So, okay, main thing. I would say, does everybody have this May Institute link? I hope so, probably. Do we need to, can we post this in the chat maybe if people need it? Where's the chat? Okay, here we go. There's that. Just in the Zoom chat, I posted that link to Northeastern website. Thank you. Oh, our TAs are, look at that. They're experts here. Thank you so much. Okay, so go to this main page here. And then on May 7th here, the hands-on, click on the docs here. And then from here, I think maybe I didn't link them here. They're on the Northeastern website on a Google Drive, but in particular, just come to this GitHub repo here at the very bottom. For now, click on that, grab that link, execute that link here, and then you can look here on the lecture slides here in the GitHub repository. You can click on day 1 and then click download. It's about 14 megabytes, so it takes a little bit, but just download it and then you'll have all the slides here. All right. Okay, let's go back to the slides. Great, let me see where we're at. Okay, introduction to RStudio here. So RStudio is a application, okay, and it's typically referred to as an IDE. That stands for Integrated Development Environment. Just think of it as an environment or a program where you can go to write R code, develop R code, and so on. It's important to note that RStudio is not R. Okay, these are completely different entities. R is an open source programming language that's developed by a core team of members who oversee how R is developed, sort of as a open source nonprofit kind of organization. RStudio, on the other hand, is a company. They're a commercial entity, very, very integrated into the R community, but they are a separate company, and they make this RStudio IDE that we're going to be working with. And you don't need RStudio to write R code. You could download the R language and you could type R code in a text editor and you could execute it in a console, but RStudio makes it a lot easier to work with R. And RStudio is used in a couple contexts. RStudio is the name of this program we're going to be working with, but it's also the name of the company that develops it. So there's some different contexts in which the term RStudio is used. Let me go here. It gets a little more confusing when we think about sort of different things here. So as I mentioned, R is the programming language, an open source programming language developed by the, I think the R Foundation or the R Consortium actually develops this and oversees the development of R. Very importantly, you install R first. You need to install that. If we're going to think about a metaphor here, you can think of R is like the engine. It's the engine of the car. Okay, the main thing that makes the car do its cariness. RStudio is the application that I talked about. That's what we're going to be working in. It sits on top of R. It allows you to work with R much more easily. If we extend this metaphor, you can think of RStudio as like the body or maybe the interior. You know, you could change the color of the seats or something like that, but you still have your fundamental car and the engine. That's what the R is. There's also Rstudio Cloud that I talked about. This essentially combines both of these things together in sort of one package and puts it on the web. So Rstudio Cloud combines both R and RStudio in one convenient package. You just need a web browser to access that, and you have the ability to run R from a web browser. What's really cool is that the RStudio environment that you see here is almost exactly like the thing you see on your desktop. So even though you're working in a web browser, all the stuff that you have on your desktop is available in the web browser. So it's really cool. As I mentioned at the beginning, there are both free and paid versions. Obviously, there's a cost to hosting these these computers in the cloud. And so if you wanted to use this extensively, they have paid versions for it. But on the free plan, which everybody has access to, you have 15 free hours to use Rstudio Cloud. And I do not work for Rstudio. It sounds like an endorsement. It's not. Just want to say it's a great tool out there if you'd like to use it. Yeah, again, in this metaphor, Rstudio is kind of like the complete car. It puts everything together for you to use it. Okay, let's get into actually doing some stuff. So what does Rstudio look like when you first open it? This is what it's going to look like roughly when you either look in Rstudio Cloud or the Rstudio desktop application. You're going to launch it and you're going to see a window like this. Looks a little boring, but there's actually quite a bit of tabs here and panes here, windows that you're going to be working on. Let me break down some of the main windows here. This main one, big thing on the left side here, this is the console. This is where you're going to type code. You can type code and interactively execute it. So this is a great place to work. We're going to be spending actually quite a bit of time in the console today doing some exercises and working through R. On the right side, we have these other panes to show you different aspects of your environment. So this is the environment here. Don't worry about that, but you can kind of see different things will populate, variables and things will populate in this environment. You don't have to pay too much attention to it today, but if you kind of watch it as you work, you'll start to see things pop up over here depending upon the code that you type. We have a file browser down here. You'll notice also there's a little tab here for plots. Plots can show up down here and so on. So these are additional pieces of the interface. We're not going to really worry about these two things today, but if you continue to use Rstudio, they will be eventually be an important piece of your workflow. If we create a new file, you can do that through File, New File, RScript. A new window is going to pop up here, and this is the editor. Okay, so think of this as a text editor. Think of it like, TextEdit or Notepad or Word. This is where you can type code and you can actually save it. And that's really important, right? If you go to do a project and you're writing a script to do some work, you're going to want to save that in some kind of file that you can refer to later and execute. The editor is where you're going to type that kind of code. All right, so these are the main ones we're going to focus on today. The editor and the console. I want you to get really familiar with these two things, recognize what they are and why you would want to use one versus the other. Okay, we're going to do our first practice time session here. This is mainly the test to make sure everybody has Rstudio working on their system and that we're sort of ready to look at the next level of exercises. So here's what I'd like you to do. So open up Rstudio or Rstudio Cloud. And get a fresh session here. And I want you to, look at the main panels here. I want you to create an editor. I want you to sort of just get familiar with them and just make sure you have those. So let's take, hopefully let's take, 2 or 3 minutes here. And I just want to make sure everybody is able to have this interface going for them. Any questions come through? I'm going to use these polls as well. They're going to ask you if you're ready to continue. So I will launch this in just a minute to make sure everybody is on track here. Again, if you have any questions, maybe reach out to the TAs here. They can maybe help with minor technical issues. All right, I'm going to launch a poll here to see how people are doing. Okay. All right, so lots of yeses here, which is good to see. All right, a couple of no's have come through, but hopefully people have had some issues, are working through those things. Okay, let me end the poll. Okay. Again, if reach out to the TAs, maybe if you have some technical issues, and we can hopefully work those out. Okay, so hopefully at this point you have RStudio up and running, and you can actually see the editor, you can see the console, and you could will eventually be writing some code there. Let me just quickly do a console versus the editor discussion. Think of the console as a place where you can experiment, you can test, you can practice your code. So I kind of like to think about this as like a sticky note or maybe a cocktail napkin where you're taking quick notes down. This is a place to test things out. The problem with the console is, in general, your work is not saved in the console. So let's say you're again trying to write a big, you're writing a script to do some data analysis. You might practice some things in the console, but really it's the editor where you want to type that code that will allow you to save the work that you've done. So think of anything you type in the code, it could in the console, it could go away at any time. It's meant for practice. The editor is where you type code and you can save it to a script file for reference in the future. Okay, and I'll show you how you can execute code both from the console and the editor. Okay, any questions about either of those things? Okay. Okay, just real quickly, RStudio can do a lot more than just execute code. There's all kinds of keyboard shortcuts. We can look at those in a little bit, but keyboard shortcuts to really make working with R much easier. There's a debugger. There are code snippets, so you can type short little keyboard codes, and it will expand out to type a bunch of code for you automatically. If you are familiar with version control systems like Git or Subversion, RStudio can interact with those. That's a more complex topic, so don't worry if that doesn't make sense. It streamlines the whole process. So writing code, you can develop packages in RStudio. You can write interactive, reproducible reports and web apps, and it's constantly being updated. So RStudio there's a ton there. We're just going to scratch the surface, but you can really dig in. There's a lot there to do. Okay, great. Now we're actually going to get into some R code now, actually typing some R code. Again, we're taking this very slowly, but step by step, we're going to do some stuff. So first things about R and how we actually interact and work with R. And I want to contrast that for how we often work with data in other kinds of software packages that are more graphical user interface based, so GUI based software packages. Let's take Excel. Probably everybody here has used Excel in some form or another. It's more of a GUI based application. You interact with the application by clicking on the interface, by going to menus, by selecting different functions and interactions. And really the interface guides you for how you work with your data. Okay, that's very different than what we do in R. In R, we interact with R by writing code. Okay, so all of the button clicks and the mouse things that you do in GUI environments, those things are sort of transferred over and captured in actual code that you type out. Okay, so I like to say with GUI stuff, you do lots of pointing and clicking, and in R or other programming, you do lots of typing. And at first thought, you might think, wait a second, GUI applications seem much better. The interface, helps me work with the program. The interface sort of guides me on what to do. Isn't that much easier? Isn't that better than typing a bunch of code? In certain circumstances, I'd say the answer to that is yes, but there's also a lot of really important advantages to writing code. And I think one of the most important thing is that code captures explicitly everything that you want to do. Okay, and that's really important for doing reproducible data analysis. Imagine if you wanted to reproduce an analysis you did 6 months later down the line. If it was a GUI application and you wanted to start from the beginning, you'd have to remember the exact sequence of operations that you did. I loaded the data by clicking this menu item. I selected this column in the data and I transformed it to these values. Then I selected this range and then I told it to do a linear regression here. And then I, grabbed the plot and I added some data to the plot and so on. You'd have to sort of revisit all of those things that you did sort of in the interface, whereas the code, you explicitly capture all the steps of the process. It's right there. It's very clear. It's laid out, and you can essentially just re-execute the script, further down the line, in time, and be able to hopefully reproduce what you did. So that's really important. Code is easy to share with others. If you wanted to share a GUI workflow with somebody, you'd have to type a big long email about step 1, load the data, step 2, and so on, and go through all the details there. Whereas with code, you just send them a file and say, hey, run it. Lots of other things here that I highlight. But essentially, code has lots of flexibilities and advantages over GUI-based software. And actually, if you get really good with coding, it can actually be faster in certain circumstances as well. You can do really complex things, writing some code, bang it out on your keyboard really quick, and you can execute it. It can actually be faster than using GUI-based software. Okay. The first thing we're going to do with R coding is using R like a calculator. This is kind of boring and maybe not too exciting, but R, believe it or not, can be used just like a calculator. It has all the standard operations, plus, minus, multiplication, division, all kinds of other stuff, modulo operators, matrix multiplications, and so on. And there's a bunch of functions as well, so you can calculate means and standard deviations and so on, as well as doing like really complex operations. All these things exist. And we're not going to talk about this in this workshop, but you can also write your own functions that you could wrap up complex operations in yourself, by yourself, that you can then call in your own code. So essentially with code, you can do anything you want, which is really cool and really flexible. Okay. We're going to get into some practice time here. Before we get into that, I want to go into Rstudio and orient you into how you can actually do some of these things in the console and in the editor. Okay, so is that large enough? Maybe TAs, you can nod your head. Is this big enough, or is it kind of small? Yes, Sarah, is it a little bigger?
Yeah, a little bit bigger, yeah.
A little bigger. Okay, this is always the challenge in these situations here. Okay, great. Is that better, Sarah? What do you think?
Yeah.
Okay, great. Okay, so in the previous exercise, remember you saw the console here, and you went to File, New R script, and you got a script. So we have these two places we can type code. So let's just do something really simple down here in the console. Let's do the amazing math problem of 1 + 1. Okay, so I typed 1 + 1. What I'm going to do now is press return. Very basic, but we just typed a line of R code and we executed it by pressing return, and we get the answer down here. Let me parse this out because the output looks a little strange here. A couple of things to note. Do you notice that this is in blue here? It's a little hard to tell, but there's this caret sign here, which is saying like, hey, I'm R, I'm ready to accept your expression. That's what that caret means. And it's also in blue. So your expressions are being typed in blue. When we hit return, it spit out this new line down here. This is in black. So the answers are coming out in black. That's a visual cue to let you know that that's an answer. The expected answer is 2, obviously, and we can see that. Notice this little bracket 1 bracket. That's kind of weird, right? This is not part of the answer. This is essentially telling us that this is the first answer of our expression here. This will make a little more sense when we talk about vectors in a little bit. But essentially, imagine if you had a bunch of answers here and it scrolled off the page and we had to go to a new line here, you would see a new little index here. It would have brackets and it would say like bracket, I don't know, 25, to note that the number, sort of the next number next to it, is the 25th answer of your expression. Okay, so just ignore this here. This is not really part of the answer. It's just a way of telling you essentially kind of how many results you have. It's not exactly that, but that's what it's about. Okay, so you can type anything here, 2 × 3 or whatever, and hit return. Okay, so we're going to do some practice of this in just a second. That's in the console. You type one expression, you hit return, and you execute it immediately. Let's see what happens in the editor here. Let's do the same thing. Let's do 1 + 1, and let's hit return. Okay, nothing happened, right? We essentially just went to a new line. This acts just like a text editor, like I said, Word or Notepad or whatever. Nothing has happened, okay? But we did save this. This R code exists here in this script. You can use the arrow keys to move around here. You can hit return to get new lines. You can use keyboard shortcuts. If you use keyboard shortcuts, say in Word, like on the Mac, if I push Command and the left arrow key, I can go to the beginning of the line. Probably on Windows, it's probably Control and the arrow key. So you can use that to sort of move around. You can use the Shift key and the arrow keys to select portions of the code. So this works just like a standard text editor. You can usually use all those standard shortcuts and keyboard operations. Let's say we actually want to execute this code. We want to see what this code does. All you need to do is put your cursor on the line. You can use your mouse if you want. Put your cursor on the line, and then you can click this Run button. I want you to watch down here in the console, in the console here when I click the Run button. Okay, so what did it do? It took this line of code. It essentially sort of pasted it down there in the console and executed it for us. Okay, so that's the way you execute code in the editor. You can also, I use this keyboard shortcut all the time. Push, let me put another line of code in here, 3 times 6. If you put your cursor on the line of code and you push, on the Mac, it's Command return, on the Windows, it's Control return, it will also execute that line of code. Okay, so that's a really handy keyboard shortcut. And you could even like select multiple lines of code like that. You could use your mouse to do that and push Command return. It will execute both lines of code. Okay, so that's how you execute code from the console, where you type one line and execute one line one at a time, or in the editor where you can type expressions there and you can execute them by selecting the lines and either clicking the Run button, or I'd like you to use a keyboard shortcut because it's so much easier, Control or Command return, depending upon your operating system. Okay, a couple other things to note. If you're down here in the console, if you push the up arrow key, it remembers the history of commands that you had. So that's kind of cool. You can sort of cycle through previous commands that you had if you kind of forgot what you did, and you can grab those and hit return to re-execute them. Let's see, I think I have a few more tips here. Let me come back to my slides. That is in PowerPoint. Up arrows, yeah. Let me show you something. And actually, we're going to get into this in the practices here. But if you get stuck in the console for some reason, let me do something like this. See this little plus sign here? This means R is kind of waiting for your expression to be completed. This is an incomplete expression that I've typed here. You have this plus key, or this plus sign here. And let's say we try to do like a math expression, 1 + 2, and you hit return, nothing's happening. It's kind of stuck. It's waiting for this expression to be completed, and we'll talk a little bit about that. If that ever happens in the console, press the escape key, and that will get you out of sort of this trap that you can get into. This happens sometimes when, particularly if you copy and paste a complex code, you might get into this weird situation where you get stuck. Just push escape, you'll get back out. Again, you're looking for this greater than sign that says R is ready to accept the command. Plus means that it's waiting for you to finish your expression because your expression is not complete. Okay, all right. All right, so let's go back. We're gonna do a little more hands-on here. I want everybody, please, if you don't mind, I want you to open RStudio. Maybe you have it open from the last exercise, that's fine. I want you to make sure you have a new script, so you have both the editor and the console on top. I want you to execute several math expressions, both in the console and the editor. So just do some simple or complex math expressions. I want to make sure you can execute them and see the results of those expressions in RStudio. And just note how the two modes of interactions are different. We just went over that, but I want to make sure you're able to do that. So let's take a couple minutes here to do that. Any questions have come up, Jays, that we might want to cover? So I saw one question here, how to get rid of lines. Susan, maybe you can, oh, rid of lines. Ah, great, that makes more sense. Okay, so in the editor, you can use think of it like a standard text editor. So if you go on a line and hit delete, that will get rid of lines. Okay, so you can just use the delete key. So think of this kind of like Word. Think the editor is like Word, but it's like Word for code, and all the same kinds of operations of working with the code applies here. So you can even use your Shift key to select code and get rid of it. Okay. All right. Okay, let me bring up my nifty polling here. Okay, good. Looks like lots of people are doing okay. Again, we're taking this step by step. We will definitely get to more advanced things here soon, but definitely want to take this step by step. So new users feel comfortable about moving forward. Okay, great. Okay, so okay, there was a question again, Susanna. Thank you for the question. Delete does not work in the console. Okay, so yeah, good point. That is a fair assessment. Let me get rid of Q&A here. Let me stop the poll. Let me come back to Rstudio. Okay, so yeah, in the console. That's correct. Delete does not work. It just has this running list of commands. Okay, again, it's kind of like a sticky note in your writing on pen. It just is kind of there. So again, just unfortunately, just kind of have to live with the messiness of the console. If it really bothers you, you want to like clear it out because it's like visually you don't like the look of it. There's a little broom button here. Do you see it? It's actually, they need to make this colorful. It's hard to see. This is a broom here in the upper right corner. If you click it, it'll clear the console out. You know, the lines kind of are still there above, and you can still push the up arrow key to get to the previous commands, but that allows you to clear it out. So usually I just live with the messiness of the console. It's just kind of a messy place to run expressions. And it's in the editor where I want to have sort of nice looking, clean, organized code. All right. Okay, okay, in this section, we have one little piece here. It's called Rstudio Projects. This is a really important way to think about how to work and organize your data analyses. And the idea between an Rstudio project is essentially just think of them as special directories, okay, that you're going to make on your system. And the idea with these directories is that you're going to put everything that you need for your analysis inside of this directory, okay? This directory is, in particular, is going to allow you to deal with this concept of file paths. So imagine you want to read a data file into R because you want to do some data analysis on it. That data file could exist anywhere. It could be in your downloads folder. It could be buried, 20 levels deep in some organizational structure on your computer. R doesn't know where to look for that data file. So you have to essentially supply a path. And that can be like this long sort of bit of words about where this file lives on your system in order to read it into R. Okay, that can be confusing, that can be frustrating and cumbersome to figure out where that is and getting that file path correct. The idea with Rstudio projects is as long as you use a project and you stick stuff inside of that project directory, you can essentially get access to that data in a straightforward way. So we'll have some examples of that I'll show you. Like I said, the idea is that you make this directory, you put everything in there that you need to work on it, and then everything is self-contained in the project file. I have some slides here that walk you through it. You can refer to this maybe after the course if you want just a reminder of how to make the projects, but let me actually just do it live for you. I think that's more useful. Okay, and there's also, we're going to take a slight diversion here. If you're on Rstudio Cloud, this does not apply to you, and it just is the way in which Rstudio Cloud works. Every thing in Rstudio Cloud is already an Rstudio project. So you can't make Rstudio projects inside of a project. So if you're just using Rstudio Cloud, please just watch along here. And you can refer to the slides for notes about making Rstudio projects. If you are using Rstudio on your own laptop or your personal computer, you're welcome to follow along with me. Okay. So to make a new project here, pretty straightforward. You go to File, New Project. Let's see, it's just asking me about this document. Yeah, so File, New Project. It's going to bring up this project wizard. There's lots of options here, unfortunately. Just in the case, select New Directory. That says we're going to make a new directory for our project. Then it asks what kind of project it is. Well, we have to tell it it's an Rstudio project. We click that. First of all, we need to say where this project is going to go. Okay, there's a file browser that you can use to browse your file system on your computer. I'm just going to use the desktop now, just to make it easy. And then let's make a test project here. Let's call it test. Don't worry about any of these other settings here. Okay, so watch over here in this corner of the screen here. I'm going to click Create Project. Okay, so it made a new directory here called test. Rstudio is kind of blinking out and reinitializing here. It's now just opened this project up. Okay, so now essentially I'm ready to work here. We're going to do a little demo here. Let me, I will do this, but also you can refer to the notes about doing some practice on this. So imagine we want to load a data file into this Rstudio project. We want to analyze it. From the GitHub repository. Let me go there just in case you don't have it. In the GitHub repository, if you go to data here, so in the main page, go to data, there's a zip file here. Click on the zip file name, click download, and it will download the zip file, unzip it. And then we have some exercise data here that we're going to be working with in a little bit. Let me get rid of that. Let's say, for example, that we wanted to work with some of this exercise data. Well, the first step would be to copy the data into our project. Okay, so let's take a look at this file here. And you can do this in your Windows Explorer on the Mac Finder. We can take a file here. This is from the exercise data. You can copy it and paste it into the directory of the test project here. Let me paste it in there. Okay, so now we have this CSV file in this project. If we come back to Rstudio, whoop, it showed up here in the file browser here, so we know it's there. And we could do something. I'm going to be typing some R code you're not going to understand, but for example, we can read this data file into R using this function called read.csv. And then we can put the name of the function, the file here. Okay, and that allowed us to read this data file into R. Key points here. One, we used an Rstudio project. Two, the data was in the directory of the Rstudio project that allowed us to directly read this file by its name. Okay, and if we make a mistake in the name, for example, it will tell us an error because it can't find that file. But in any case, as long as you do those kinds of things, you can read the files into R. Let me take a look at Q&A. Any questions? Okay, looks like some other sophisticated questions. That's fine. Okay, great. Okay, let's go back to our presentation here. So that's Rstudio projects. I have a little practice time here that I kind of went through interactively. But anyways, you can refer to this as well to work with Rstudio projects. Okay, so that closes off the first section where we're talking about using Rstudio. Is there any questions around that?
To slow down, so maybe.
Yes, thank you, Sarah. Okay, yeah, let me slow down a little bit. I will try to do that. At this point, I think that the main thing that I want people to be able to do is to be able to have Rstudio open, be able to see the console, to be able to make a new script, and to be able to execute basic code like 1+1. Okay. Okay, we're going to get into some R syntax here in the next session, so I will try to slow things down a little bit as well. Okay, let me bring up my polling tool here. Okay, so does everybody feel comfortable at least taking Rstudio, being able to execute code and run it. So we have a few no's coming through. Maybe reach out to the TAs if you have sort of specific questions or specific pain points. And let me point you again to the Rstudio Cloud option as a way to getting sort of this environment without having to have R installed. Again, it's on the May Institute website here under the documents, and you can follow if you scroll down, the Rstudio Cloud option here to get set up with Rstudio Cloud. Okay, great. Any other questions that have come up? Sure. You want to cover? Okay. Okay, let's now go to the next session. We're going to start talking about some actual fundamentals of R coding, sort of the first steps, writing more code than just doing some basic math operations like a calculator. Okay, so the goal of this module is to essentially how to do some very basic things with R. Again, we're going to be typing expressions, we're going to be typing some code, and eventually start doing some more interesting things here. Want to understand some essential R syntax. We're not going to go through all of the language features here, that there's too much to cover in an introductory course, but we're going to try to cover sort of the main things that will be hopefully of use, so that when you're done with this workshop, that you can maybe start to do some basic operations on data afterwards. In particular, we're going to talk about this idea of variables, how to work with them. We're going to talk about vectors and conditional expressions, and then a little bit about using some of the essential functions that R provides to do some common operations, like taking the mean of a list of values. That's a really common data analysis method. And so we'll talk about how we can use some of these built-in functions to do some of these operations that you're probably doing, say, in Excel already. Okay, so the first thing we need to talk about is this idea of syntax. So think of syntax as the set of rules that define whether or not a certain bit of R code that you type is correct or not. Okay, so again, we're going to be typing code in R using characters and numbers and symbols. How all these things are arranged and written and typed are going to be judged by the language about whether or not that is correct code that you've just written. And you're often going to find that, particularly in the beginning, you'll probably be making what are known as syntax errors, like you have a parentheses that's out of place, or you've written something unexpected and it's out of place, and you're going to get an error message. And these things are going to be frustrating. You're going to make these syntax errors all the time. It's just a part of the learning process. Even people that have been using R for a long time make syntax errors as well. I make syntax errors all the time. But the key is, as you get more experience working with R, is you'll get better at noticing syntax errors. When you make them, you can say, oh yeah, I forgot that little parentheses here or there, and you can go and fix it. And essentially through experience, you'll be able to correct these syntax errors so that you're typing code that's correct and not getting errors out. Okay, so that just comes with experience. Like I said, just hang in there. These syntax errors are going to pop up all the time and be very frustrating, but it's just a part of the learning process. To note that computers are very, very picky. Even a single mistyped character can cause a problem. Okay, so when you type expressions, they have to be 100% syntactically correct. Okay, even one little out of place piece will cause an error. Okay, so imagine you've typed 99% of the code correct and it looks okay on the screen. There could be one little thing out of place and it will give you an error. So just be on the lookout for that. In terms of sort of math expressions, it follows sort of the basic rules of mathematical expressions about grouping things and so on. it's a good idea to, we'll see this in some of the code, but make sure you can put spaces around your operators and your various symbols. I'll show you that as we type code. But that's just part of making good code that's easy to read. And things like quotes and parentheses and brackets, they almost come in pairs. So you can't just have one by itself. So if you put like a parentheses, we'll see how we do this with functions. You'll have an open parentheses. If you don't have a closing parentheses, then that's not a correct expression, and you'll run into problems with that. So some of these things come in pairs. The error messages that R prints out, these will show up as red. Actually, let me show you one of these errors here in RStudio. Here, well, this was a particular error here. We tried to read this data file in, and we misspelled it. It printed out an error here. It's in red, so you'll notice that that's nice. It's an error if it's in red. Usually there's a message here about it. Sometimes these messages are helpful. A lot of times they aren't helpful, unfortunately. But we got a clue here that it says cannot open the connection. So it gives us some idea that it wasn't able to find this file. Okay, so it sort of implies that maybe we spelled this file name wrong. Okay, but just note errors pop up in red. Sometimes the messages are helpful. Unfortunately, sometimes they're not. But what it is useful is to Google for these things. So for example, you could copy a particular error, you could copy and paste that into Google and maybe get some information about the error and some more details about what might be going on. Okay. We're going to talk about one of our first important concepts here. It's the idea of variables and assigning variables. Okay, so variables make your code more understandable. Okay, and an idea behind a variable is essentially taking some kind of name here and being able to assign a value to it. Okay, and this is just a very simple example here, but I am in this line of R code here, I'm creating a new variable called my_var. Now I'm using this assignment operator here. This is really kind of weird. It's the less than sign followed by the minus sign. Okay, those come back to back. There's no spaces between these two things, and you have to type both of those characters here. This is meant to look like an arrow pointing to the left. And then you have something on the right-hand side here. In this case, it's the number 10. So think about the ideas that we're storing the number 10 in this new variable. We can name it almost whatever we want. We'll talk about that. But we're assigning this value 10 to my var. Okay. Why would you want to do that? Why would you want to use variables? Well, variable names actually can give you context for the data. Imagine you wanted to store, say, the length of your experiment in your script. Okay, that might be something like your experiment took 60 minutes to run. You could just type the number 60 in your code and do some data analysis on that, but that doesn't have much context. We don't know what the number 60 necessarily means. Alternatively, you could make a new variable called experiment time and assign that the value of 60. Then whenever we use this myvar variable, we now know that we're referring to experiment time and it has that value of 60 in it. So we can do math using these variables, for example. And it gives you context to the data that you have. It's also useful that, let's say we needed to update the value of the experiment time. Let's say it was actually 45 minutes instead of 60 minutes. If you had typed 60 throughout your code, your script, you would have to go back and find every instance of where you typed 60 in that context and change it to 45. Whereas if you used a variable, you'd just have to change the one instance where you assigned that variable that value. You could update it in one place and all the code downstream would essentially have that new value of that variable. Okay. I'm going to show you some examples in Rstudio about making these variables and some code about how we can do that. Naming variables is up to you. You're mostly free to name them whatever you want. It's up to you. And actually, it can be challenging sometimes to make well-named variables. If you make the variable names too long, then you have to type stuff out. That's kind of cumbersome. If they're too short, they may not have very much information or meaning. So it's sort of an art to naming your variables well, but try to name your variables with some information about what kind of data they're trying to capture. There are some rules here. I outline these here, so they can only be letters, numbers, underscores, or periods. You can't put spaces in them, for example. So everything has to be mashed together. And there's some other things about like not starting with a period or an underscore. Here are some examples here. We don't need to go through all of these here. These are all valid variable names here on the left-hand side here. The ones on the right, these are all invalid variable names. We'll see what happens if you type an invalid variable name. You will get an error in the R console. And maybe not necessarily right now, but you could go back. Why are these invalid here? You know, there are rules that are getting violated here about why you can't use these as variable names. In regard to variable names that are meaningful, these ones really aren't all that meaningful. MyVar in different forms isn't all that useful, but like gradient minutes, that's actually a good variable name. It tells us, you know, maybe we're using an LCMS system and we want to store the value of the gradient time. And so that's a useful variable name. The minimum MZ maybe of a mass spectra or something. So these are useful variable names that you can use. Okay, we're going to get into some practice time here, but let me show you some examples of making some variables here. You can type this in the console, probably easiest right now for just doing these quick expressions, but you could also type them up here in the editor. But let's make a new variable. Let's call this gradient underscore minutes. Again, it all has to be no spaces here. So we can't have a space there. We need to make all one sort of word, if you will, and a lot of times you use underscores to do that in R. I'm going to push another space here. I'm going to push the less than key, the minus key. I'm going to push another space, and I'm going to put 60. Okay. Let's see what happens when we execute this. Nothing kind of happened here. We did nothing returned here, but it actually did do something. It created a new variable in our workspace and assigned the value of 60 to it. And actually, if you peek over here in this little pane over here, you can see that we have a variable called gradient minutes, and we can see its value there. Okay, let's see what happens if we just type gradient minutes by itself and hit return. That will just print out the value of that variable. Okay, so we can see what it is. Let's do that over here, up here in the editor. So gradient minutes. Again, we're going to put spaces around here. I think this is useful for readable code. The less than sign and the minus sign, and we'll put 60 here. Okay, and again, if we push return, it's not going to execute that code. Again, this is just like a text editor. If we want to actually run this line of code, we need to click the run button. Or we can put our cursor on the line of code and push command return. That will also execute the expression. Let's say we change this to 45 and we can execute this line again. Look what happened over here in our environment. That value got updated because we executed this code in our environment updated to show that. Okay. All right, so let me come back here, come back to my slides. We're back to practice time here. So what I would like you to do is bring up your RStudio environment. Again, I'd like you to create a variable here. Here's the name of it. And I want you to assign a value of 10 to it. Do some practice here about working with that variable. And then I want you to create another variable. I want you to add those two together and assign it to a new variable. Okay, so kind of piggybacking on multiple concepts here, the idea of adding things together, which we did previously, and assigning those results to a new variable. And then I want you to see what happens if you update one of these variables and how it does or does not affect the other variables that you made. Okay, so let's take, this one's a little more involved. Let's take, 3 minutes or so to go through this. Okay, there was a question from Christopher about the difference between this assignment operator, which is the thing that looks like the arrow and the equal sign. You can use the equal sign to do variable assignment as well. Certainly valid to do it. You can do it and you can execute the code and everything will work as expected. The R community has, I would say, consolidated around the use of the assignment operator, the thing that looks like the arrow. Okay, that's what you're going to see hopefully most of the time in sort of well-written R code. It's just by convention. Okay, so in this case, there is really no difference. You can use both, but the suggestion in the sort of the proper way, if you will, to do assignment is to use that thing that looks like the arrow. Okay, Angelo, okay, this is a great question. Is there a keystroke to switch between the input from the editor to the console and vice versa instead of clicking? Great question. Great question. Yes, because I do that all the time. So if you go in RStudio, if you push, let's see, what is it? Yeah, okay. Windows, and Angelo, if you're on Windows, maybe you can confirm to us if this works or not. But at least on Mac, if you push Control-1, look at the cursor here. It's blinking here. That means that the editor has focus. Control-1 will get you to the editor. If you push Control-2, notice the cursor is blinking down here in the console. And you can go between the two. So Control-1 and Control-2 are the keyboard shortcuts to do that. Okay, actually, great. Okay, all these good questions. If you accidentally typed something, a variable name wrong, for now, re-execute an expression where you have the correct name. You can't go back and sort of fix the variable name that you incorrectly did. So in this example here, just retype the name correctly and re-execute that. Great. So Angelo confirmed that if we go between Control-1 and Control-2, you could go between the two. And that's a good point, because sometimes I will be thinking I'm down here in the console and I'll be typing stuff up here accidentally in the editor. And I'm like, where's my code? I expect it to be one place and not the other. So anyways, just be aware of that, sort of what pane has focus. Look for that blinking cursor to guide you there. Ooh, that's great. So somebody had mentioned that there's a way in the panels button to do some add-ins here to essentially add some new shortcuts in there. So okay, great. Control. Okay, Rstudio Cloud. Thank you. Somebody mentioned in Rstudio Cloud that these shortcuts don't work. Okay. That might be a little piece of the web editor that's not working, unfortunately. Okay, so let's these are all good questions. Thank you. Let's get back to the practice time here. Hopefully people had a chance to do it. I'd actually like to work through these examples with you here so we can go through these things. So let's come over here. So I think, what did I say? We wanted to get a new variable called exp. I don't even know what my own example here. So we wanted exp1 time 1 here and set this to 10. Okay. So like I showed before, if you execute an expression like this, nothing is going to return on the console. But if we type the variable again by itself and hit return, we can see the value of it. Okay, and then I asked you to make a new variable called exp time 2 and set that to 20. Okay, so hopefully that's straightforward. And again, exp time 2 is 20. Then I asked you to add those together, and I think I said exp times sum or something like that. So again, I'm just typing the names of these variables, completely up to you, but I think it's important to make them sort of represent the data that they're storing. So if we do exp time sum, we can do exp1 time plus exp2 time. Okay, so remember we did math expressions before where we had 1 plus 1. Now we're doing expressions here where we're using variables again, and so these variables are going to stand in for numbers. So expt, this is like adding 10 to 20. Okay, so let's execute that. And if we type exp time sum, we can see that that is in fact the sum of 10 and 20 together. So now we've done a math expression all through variables, and we're able to save those results out. Okay, I think it's the last piece I wanted to note something. Let's say we took exp time and set that to 30. Okay, remember it was 10 before, and now we're going to set it to 30. What do you think the value of exp times sum is now? Okay, so we updated one of these variables, right? What do you think exp times sum would be? Well, we're in code, so we can actually, nice thing, we can do the experiment. We can just type the value of that variable and hit return. Okay, well, it's still 30, okay? It's not, we updated exp time 1. The value is not 30 plus 20, it's not 50. Why is that the case? Because this line of code was executed before we updated one of the variables in the expression. Okay, so if we wanted now this new expression to represent the fact that we updated exp time 1, we need to re-execute this expression. Okay, and then it will get the update. A couple ways you can do that. Let's use the keyboard shortcut of pushing the up arrow a couple times. Okay, so that allowed us to recall that expression we typed above, so we don't have to type it. We can hit the return. Now we've re-executed that expression with this updated exp1 underscore time. And if we type that, sorry, time sum, I mistyped the variable name there. We exp, see, okay, great example of an error message here that popped up. It says object, this thing not found. That's because we don't have a variable called exp1 times sum. There is no 1 there, so we got to get rid of that 1 like that. And we can hit return, and we can see that it is in fact 50 now because it's used the updated execution of that variable. Okay. Okay. Great. So I think that goes through those practice sessions here. Any questions about variables, executing variables, the order in which variable membership would affect how assignments work? TAs, anything popping up in the Q&A? Okay. Again, if you have questions here that you're not comfortable asking right now, go ahead and write them down and we can cover them at the end as well. Okay, let's go to the next topic here about vectors. What is a vector and why is it important? A vector is known as a data structure. Okay, if you were to take computer science curriculum in college, you would probably have a class that you would take called data structures. Just think about these as, I like to maybe call them bags or something, different kinds of bags that hold data in different ways. Okay, so just like if you go to school, you know, there's a bag for that, right? A backpack. And a backpack has some function about like storing your notebooks and your pens and pencils and so on. And a backpack is useful going to school. If you were to go on a long trip, you may not want a backpack. You may want a suitcase instead because it has a different purpose, and you may want to pack a lot of clothes in your suitcase. So data structures kind of work the same way. There are different kinds of data structures to hold different kinds of data for different purposes. Okay, so the idea is that we want to hold a bunch of data together for some reason. And a vector is one of those data structures that we're going to talk about here. A vector essentially is just a thing that holds a bunch of individual values. So far, we've been doing very simple things like adding 1 plus 1 or single entities together. Vectors will allow us to hold a bunch of things together at the same time. And we'll see some examples of that. Towards the end of this series, and also tomorrow, we're going to be talking about data tables. That's another kind of data structure. It's different than a vector. It holds a two-dimensional table of values with rows and columns. You can contrast that to a vector. A vector is like a one-dimensional thing. It just holds, say, like a row of data, whereas a data frame, or another strange name for it, but as a tibble that we'll talk about, holds tabular data in two-dimensional forms. Okay, so let's talk about vectors. So first of all, vectors hold sets of data. And in particular, these types of vectors all need to be the same type. What do I mean by that? Well, if you're holding numbers, everything inside of that vector has to be a number. You can also hold words for example, those are sometimes called characters or strings. You inside of vectors, you can't mix characters and strings together. So essentially, if you're holding a vector, it has to be all the same type. And typically, we're dealing with numbers. That's what we're usually going to be working with. And let's think about why we'd want to use vectors. Think of a mass spectrum. You have, for example, mass to charge ratio values, so M over Z values, and you have a lot of those, right? You just don't have one. You have one that go across the spectrum, and you might also have another vector that could hold intensity values for essentially the intensities at each M over Z value. These are two separate vectors here, and you can imagine these things sort of coming together to represent the mass spectra. So in some sense, you could represent a mass spectra with two vectors, one to hold the M over Z value, one to hold the intensity values. Okay, let's talk about how we make vectors and how we can assign them to variables. So here's a basic pattern here. We have a variable name here on the left side. This is like we did before. We have our assignment operator that looks like an arrow. Now, instead of having a single number, we have to do some additional work. We have to type some additional code. It's going to look a little strange here, but I'll describe to you what that is. First, we're using what's known as a function. I'll talk about functions a little bit more later, but this is the C function. It stands for combine. Essentially, it's saying, I want you to combine a bunch of values into a single thing, into a single vector. So we have this, you have to type the letter C and then an open parentheses. Then we can put a bunch of numbers here, separated by commas here. And then we have to make sure you put close parentheses at the end. If you don't do that, the expression is not complete and it won't work as expected. Okay, so essentially we're wrapping all of these values up together in a single thing called a vector. And we're assigning that vector to a new variable called myvec. Okay, so it looks very similar to what we did before, just with some additional little code here. And we have all these values here that we can sort together. Okay, we can, just like we did math with individual numbers, we can also do math with vectors. And this is actually really powerful to do. And the idea here is that we can perform math very similar to what we did before, but instead of working on individual values at the same time, we can actually add, for example, two vectors together to do a bunch of computations essentially at once with one line of code. There are two patterns for this, and we're going to practice this. So, but just keep this in mind. There's one pattern where you take a vector. Remember, a vector has all of these values here, multiple values, and we add to it a single value. Or you take vectors that are importantly of the same length. Okay, so just like our mass spectrum example that had multiple vectors, these vectors should be the same length. Looks like we had a question, a hand that popped up. If you want to ask your question in the chat, we can cover that. Let's see here. Okay, great. Let me just cover this real quick. So there was a question about the different names for similar kinds of bags in other programming languages. So we talked about a vector. That is a specific thing in R. The equivalent thing in Python would be called an array. And in Java, it might be like an array list, I think, if I remember correctly. Essentially that these bags have different names in different contexts. And unfortunately, sometimes those names are used similarly or differently in other contexts. So just kind of have to pay attention to the nomenclature that a particular language uses. But you hear names like vectors, arrays, lists, and so on. These are common names that get used sometimes similarly and sometimes differently, depending upon the programming language. Okay. All right. Sorry, that was a little diversion there, but I think it was important to point out that naming. Okay. So again, if we're going to be working with vectors, either we're going to add a vector to or operate a vector in a single value or vectors of the same length. Okay, it is possible to operate on two vectors of different lengths. R will let you do it, but don't do it. Don't do it. This is definitely a more advanced kind of operation to do and will give you unexpected results. So please don't do that. Make sure if you're going to operate two vectors together that they are the same length. Okay, here is some example code, and actually I'm going to have you execute this code in our example data, but here's the code on the left and output on the right. If you look at this, you can see this assignment operator. This allows you to assign data to a variable. And then we can work with this vector. So for example, we can add 1 to the vector, and the results that come out, perhaps unsurprisingly, is that it adds 1 to every item in the list. That's actually pretty cool. We just did essentially 5 calculations in 1 line of code, okay? You can also use multiplication there. And again, element by element is going to multiply each element by 2. Whoops. You can add 2 vectors together. So let's add myvec to myvec. It's going to pairwise add up the 2 things together. So 30 plus 30, 40 plus 40, and so on. You can subtract vectors as well. And then you can also, this is with 2 different variables, but you could also explicitly define a new vector here like this and do a similar kind of result. Again, this vector should be the same length as the other variable here. Okay, I think there was a question about what is the C operator. Again, the C is just, think of it as a shortcut for combine. It's just saying combine values to make this vector. And this is just the syntax in which you do it. You use the C, the open parentheses, list your values, and use your close parentheses. You just kind of have to digest that and memorize that as a pattern that you use to make vectors. Okay. We're going to do some practice here in the next practice time. What I would like you to do here is go back to RStudio, and I'd like you to, you can do this in the console if you like, or the editor. It all depends on what you'd like to do. Let me get back to my slides. And I'd like you to go back to, well, first of all, I want you to make your own vector. I want you to practice typing the code to make a new vector. Pick a name for it, whatever you'd like, and assign it the values through 1 through 5. I actually want you to go and type that out. I want you to get practice about typing that and execute that expression. Once you do that, then I want you to go back, and you can try copying and pasting these code examples from the previous slide. If you're really ambitious, you can try to reproduce. Let's see, if you can try to type this code by yourself again to try to reproduce that without copying and pasting. And then this last little thing, we'll cover this in the live coding. I want you to try to add a vector here to another vector that has a different length. Remember, my vec has 5 values, but we're going to try to add this to a vector with 4 values. We'll take a look at what happens. And again, I don't want you to do this in real world. I don't want you to combine vectors of 2 different lengths, but I want you to show you what happens there. So let's take a few minutes here to go through these examples. So. Okay, there was a question about only seeing the console and not the editor. The editor will only pop up if you, let me get rid of this here. The editor will only pop up if you go to File, New File, Rscript. Okay, that will give you a new editor window here. Okay. I didn't mention this, but if you click on the disk icon here or push Command or Control S, that you can save this file as an R script here. For example, we can save that, and then that script will appear in your editor. And we will take a break here in just a little bit. I know we've been going for quite a while, so we'll take a break here shortly. Let me come back to our questions here. Okay, there's a question, can we have multiple R scripts in one project? Yes, you definitely can. Okay, yeah, sorry, so let me answer. Focus here. So you can have multiple scripts here. So how do you do that? Well, we have one script here called test.r. We can go into File, New File, R script. It's going to make a new tab here in the editor. Okay, and so this is untitled, and we can type some code in here, and we can save it like before. Call this test2 and save it. It will pop up over here in the file browser, and you can also come over here in the different tabs to get to those different scripts. If you close them by accident, you just click on them over here in the panel, and you can get them there. Okay, there was a question about setting up directories and working directories and importing data. I can cover that at the end, but I'm going to very specifically refer you to the section where we talked about setting up RStudio projects. And the idea there is to make an RStudio project and then make sure your data lives inside the directory of your RStudio project in order to reference it and get it into R. Obviously, in real world cases, you're probably going to have more complex situations where data lives in other places, but we can cover that at the end. So, Raja, so go ahead and maybe note that thing and note that question, and we can talk about it at the end. There was a question about importing data via CSV files or Excel files. We actually have a little section here coming up where we're talking about data import. Let me address that question then. There's really no main advantages to either one. It's just different ways of getting data into R. And then a question about multiple scripts. It all depends. This is all about organization, how you want to organize your project. It's really up to you. An advantage of having multiple scripts is if you have a very complex workflow or data analysis that you're doing, it might make sense to chop those up into individual scripts that sort of follow that workflow. And so you might choose to do that. And one thing I often do is I might make a new script here. And I do some code here, and I'm going to save that. And sometimes I'll put like a 0-1 in front of it to say like import data like that. Okay, the one sort of that's the first thing I'm going to do to import the data. And I might have some scripts here that imports the data. And then I might have a new R script. And I'm going to call that, say, O2. And I'm going to analyze data. Okay. So it's all about how you want to organize your structure is what it comes down to. Up to you about that. Okay, so let's see, you're coming up on 9:30 here. Let's see, how's everybody doing? Can I relaunch this poll here? Were people able to do these exercises, execute them? A few no's here. I would say maybe sort of reach out to TAs here if there's like any like fundamental sort of roadblocks. We want to certainly get through those. And noting again, the materials and everything are online on the GitHub, and we can review obviously questions you might have tomorrow as well from today. So we'll have sort of layers to address different things. Okay, let's come here. I'm going to mute my messages so we don't get funny text messages that come through. Here we go. Okay. All right. Okay, let's do this here. I think you were probably able to maybe copy and paste some of these examples. Let's get this my vector here, this assignment here. There's a lot of code here, by the way, lots of parentheses, there's commas, there's this assignment operator. You have to be careful to, make all those things, make sure you type those things correctly. Otherwise, you'll get a syntax error. Right. So again, if we type my vec, we can actually see what that looks like. We have 5 values here. If we add my vec to itself, what we've done is element by element, y is added it to itself. So 30 plus 30, 40 plus 40, 10 plus 10, and so on. Okay. So hopefully that makes sense. Let's do this last little example where we actually try to add 2 vectors that are not of the same size. Remember, I'm asking you not to do that. Let's execute that. Okay, it actually worked. Okay, it actually gave us back an answer here, but it also gave us a warning message in red. Okay, and essentially it says the longer object, that is the myvec, that thing is longer because it has 5 elements, is not a multiple of the shorter object length. The shorter object is this thing here, this vector that has 4 values. So what did it do? It actually did this weird thing called recycling, where it added 1 to the first element. So let me get myvec back up. All right, so it added 1 to the first element to give us 31. It added 2 to the second element to give us 42. It added 3 to the third element to give us 10. It added 4 to the fifth element to give us 50. Then it went back and wrapped back around and added 1 to the fifth element. Okay, so it ran out of things to add together and went back to the beginning to start adding again. Okay, generally that's a weird thing to do. You can get unexpected results if that happens. That's why I always suggest that you don't do that. And if you get this warning message, go back and check your code because something in your vectors is odd about their lengths. Okay. All right. Okay. Okay, so we did some vectors here. Let's take a quick, I think at this point, let's take a 10-minute break, and we will sort of wrap up this section on functions and conditional expressions here. So it's 9:40 right now. Let's take a quick 5-minute break here just so we can keep going, so we can refill our coffee cups. We'll come back at 9:45 and get started again. So great, thanks. And feel free if you need to ask some questions in the chat, go ahead and do that. A couple questions coming up here. Let's see here. Can we execute an external R script from within a current R script? Yes, you can do that. And we can use that using, we haven't talked about functions, but there's a function called source. Let me get my test script up here. Let's do it just a my var equals 100. This is a simple script that assigns this variable to 100. Let me save that script. Now in my test2 script, I can use this source function, okay? And then we're gonna put quotation marks and we're gonna type the name of that R script, okay? So now we're sourcing the test.R script from the test2.R script. And let's see what happens when we do that. We can execute this line of code. And we got, remember I assigned my var to the value of 100. So if we type my var here and hit return, it's 100. So essentially we executed a script from another script using the source function. And you just have to put the name of the script inside of the quotation marks. Okay, so hopefully that was useful. Okay, good question. What is that 1 in front of all of the console output? Right, I briefly covered this at the beginning, but it's good to note that. This essentially tells us that this value here is the first element of our output. This is going to, let's make a really long vector here. Let me do this. You're not going to understand this syntax, but let me make a really long vector here. Let's see what happens here. So just for people that want to know, remember the C function, that's what we use to make vectors. I'm going to use a new syntax here with the colon operator that essentially makes a big long list of values between these things. So 1:100 is going to make a big long list of integers from 1 to 100. If we execute this, look at the output here. The 1 here says that this is the first element here in our output. And then it printed a bunch of other stuff out. And then there was so much stuff that it had to go to a new line. So now it tells us that this item is the 25th element of our output. and so on. And this is the 49th. And so these are just little, think of these as like little markers to tell how much data has been printed out to the screen. Okay, it's not actually part of the output. Okay, no math would ever be done on these numbers. This is just for visually looking at the output of the results. Okay, let me get some other. So there was a question about sourcing an external script. Should it always open in the current project or just placed in the same folder? Okay, yes, to source an external script, you don't have to open it so that you can see it. Don't need to do that. It just needs to be present in your folder. But it's also important to note here that if you edit the script in some way, like let's say in our test.r, we set this variable to 25. Look, you can see that it's red and has a star mark. That means it's not been saved. The script has not been saved. So if we were to run this script as is, it would refer to the old version that we had before we edited it. So just make sure you save your source scripts before you execute them. Otherwise, those latest changes are not going to reflect in your work. Okay, let's give it one more minute here. And let me note here, we're covering lots of material. Obviously, it might be a little overwhelming. I would say sort of step by step, and even if you can't grasp, all of the main concepts, try to take hold of things here and there that can give you a handhold that you can then use to refer to this material in the future and other materials to start making sort of step-by-step progress. Okay, so please don't be discouraged. It really does take time and effort and just time going through this stuff. It's just part of the learning process. Okay. All right. Okay, we're about, let's see, Eastern time, 9, 10, 11, 12, 45. Okay, we're a little more than halfway through. Let's see, it's 10:40 or not. I'm sorry, I'm on Pacific time. So anyways, it is about 9:45 Pacific time, 12:45 Eastern. Let's keep going on the essential R syntax here. We're going to talk about a key thing called functions. Actually, let me pull. I want to make sure everybody's back here. Let me restart this poll. Are people back? And we'll get another minute here. Get more people back. All right. Majority of people are back. In the interest of time, I think we need to push forward here. Okay, so then the next concept that we're going to talk about, like I mentioned, are functions. What are functions? Functions are, think of these as stored routines or stored operations that allow you to take inputs. Those could be numbers, those could be more complex objects like data frames or data tables, and will give you back something new, ideally, something that's been transformed in some way. So an example of a function that we'll see here is, say, the mean function that, for example, would take a vector of values and compute their mean value. Okay, functions are useful because you could write out the mathematics of computing the mean of adding numbers together and dividing by the length of those number of values that are there, but that's cumbersome, right? So functions are a nice way to wrap up more complex operations and essentially use them to do things without typing too much code. Functions have both names and inputs. So just let me give you an example here. So here's the name of a function here. We already used one function before, the C function, the name of that C that that C combine function that we use for vectors is C, that's its name. Then we put a parentheses here to say, okay, we're starting a function. We need to give it inputs here. And we can supply those. And sometimes there can be multiple inputs. So you might have to put a comma here. Again, with the C function, we had multiple inputs because we put all of our numbers inside of that vector. So we separated those with these commas here. And then you have to use the closing parentheses on the end. Okay. We'll see some examples here in the next slide. Base R, that's essentially the R that you get when you install it from scratch without doing anything else, has a ton of functions in there available for you, ready to use. And we're going to see some of these, but that makes it useful for starting to do some data analysis just by using R with its capabilities out of the box. You can also install additional R packages that give you new functionality. So for example, there are packages designed for mass spectrometry, packages, for example, that Olga and her team developed for dealing with and working with mass spec data. Those packages provide new functions that do very mass spec specific oriented kinds of operations that are really useful to do without you having to go and write all the complex code and mathematics to get those things done. So functions are really, really useful, a fundamental part of doing any kind of work with data. Let's look at some of these functions here. Like I said, there are a lot. I'm just highlighting some main ones that you might use. You can use this length function that will give you the number. It will return an integer number, the number of values in a particular input. If you give it a single number, it will return the length of 1. If you give it a vector, it will return the number of elements you have in that vector. Again, if you have vectors here, you can find the minimum element, the maximum element. You can sort those entities. You can get the number of unique elements. You can get things like mean and standard deviation using these functions. I bet you can guess if you wanted to get the median of a set of values, what function would you use to get the median? You would use a function called median. You just type it out. So lots of times the names of the functions represent the operations that they're doing. They should hopefully be descriptive, but that's not always the case. So I think in Excel, I think the standard deviation function is stdev or something like that. I kind of forget. In R, you use sd. Okay, so these names are important and you have to spell them right to make sure they do what they're supposed to do. Here are some example codes like we did with the vector data here. In this case, we're making a new vector here. And then we can do all kinds of operations on that vector. One thing, note that we've duplicated this value of 20. There's no reason you can't have duplicate values in your vector. There's nothing that stops you from doing that. And so, for example, if we look down here at using the unique function on this vector, it's only going to return the unique values that are present here. So it gets rid of the duplicate 20 because it's only the unique values are going to show up. So again, just to recap, functions have a name, then followed by open parentheses. Then you put the inputs, and those inputs are going to depend upon what the function expects to have. But in this case, we're just doing simple operations on vectors, and so we're going to supply that vector here. And then importantly, you have to put that closing parentheses here. Okay. It's time for practice time again. I'd like you to go through again, working with vectors, but we're also going to use some functions here from this previous example. You can use some of these here, for example, to get some information about the vector. Okay, so for example, I'm going to ask you to create a new vector. So maybe try to do this from scratch. Try to recall in your memory from the previous section how we can make a new vector with values 1 through 5 and assign it to a variable. So try to recall maybe some of those ideas we explored previously. I want you to confirm that this particular vector has 5 elements and use a function to operate on this vector to make sure that you're right. And then try some of these other things. So try to misspell the name of a function and see what error message pops out. This last one, try leaving off the ending closing parentheses and hit return on the expression that you use. I want to kind of show you the error that pops up and how you can get out of that. Okay, so let's take a few minutes here to go through some of these examples. And just using functions on vectors is the key thing we're trying to do here. Okay, there was a question about how to sort data. In this particular table here, there is a sort function. Okay. In reality, you might have another question. You may, if I did not include the sort function here in this table, you would not have known in advance how to do that. So what you could do in probably real world situation is you go into Google, and well, actually let's just do it. Let's see how well Google works here. So R sort vector. Let's see what happens here. And there are some documentation here in Google. So that's how you could do that. I'm going to show you how to get to this help information in just a second. But the thing about R is there are hundreds, thousands, probably more than that functions. Understanding what exact function you want and need to use, you typically have to rely on sort of search methods, Google and so on to be able to find what you're looking for. But that's usually a good place to go to do that. One other little tip here, if you want to understand what a function does, you can type the question mark and then the name of the function. Okay, so let's do question mark sort. No space there. I just did question mark and typed sort. And I hit return. The help documentation for the sort appears over here on the right-hand side. This documentation sometimes can be pretty verbose and might be a little complex to read, but hopefully by looking through this, you can get some idea about what it does. And in fact, let's take a look at this here. Sort has this additional argument that you can put in here about whether or not you want this sorting to occur in decreasing order. It's currently set to false. This is a logical vector here, but if you were to change this, this sort, actually, I'll just do an example of this when we go through it, but if you were to change this to true, it would actually sort in the reverse order. Okay, great. Okay. So in the interest of time, let's proceed. I'll work through some of these examples here, in case you weren't able to get them. So the first thing was in the console, we wanted to create a new vector with the values 1 through 5 and assign it to a variable. Okay, so I can do that here. Again, I think it's good practice to try typing this out over and over again so you can get used to typing proper R syntax, and we can just do that. So again, we use the C function. We just learned about functions here. We have an open parentheses. We have a bunch of arguments here that are separated by commas, and we have all the values that we want to store, the numbers 1 through 5. So if we execute this now, we can then type my vec just to confirm that it in fact has the values that we expect. Okay, let's do some operations on this vector. Let's like do the length of my vec. But it's always nice to have some expectation of results when they come out. What would we expect this answer to be? How long is this vector? And what does length mean in this case? It means the number of items that are in this vector here. So since there's 5 things in there, it returned 5. Let's actually add one more item. Let's add 2 more items. Let's add 10 and 20 to that. The length of my vec is now, should be 2 more. So, okay, it's 7. Okay, so this is how you can get information about a vector. Let's take a look at this, the sorting example here. So sort my vec. Well, it was already sorted in ascending order here. So the output is actually the same as the input. But let's remember this. I told you if you do ! sort, you can get the documentation on the sorting function, and there is some interesting things here. So decreasing, if we actually come down here, there it describes what this decreasing means. Should we sort be increasing or decreasing? By default, it tells us that it does decreasing ordering is false. But let's take this again and let's do sort my vec. We're going to have a comma here because we're adding a new argument to this function, and we're going to say decreasing, just like we have to spell it right. Decreasing equals true, all capital letters. This is a logical argument. We'll touch on this in a little bit. If we hit return here, we have now sorted the vector in the opposite direction from high to low. Okay. So how did we know that? We went to the documentation of the sort function and we looked at the data here. This is a little more complex, definitely, what we just did here. But the documentation can give you some hints and will be useful as you learn R more. Let's put this back to false. Okay, the default here. It gives us back essentially the same thing as if we hadn't even specified that option at all, because by default, it sorts a vector from low to high. Okay. I think there was one more thing I wanted you to do. Let's try misspelling the name of the function. So let's leave off the O here. It gives us an error. We spelled the function name wrong, and it says could not find the function SRT. Okay, so this is pretty informative. It tells us exactly what happened. Essentially, it means you probably misspelled the function. So go and look at the name you used, type it correctly, and then you can get the results. The last thing I wanted to show here is, let's say you forgot to leave the closing parentheses off, and you hit return. Recall that this greater than sign is essentially R saying, hey, I'm ready to accept an expression here. And if you see a plus sign, it says, whoa, wait a second, your expression's not complete. I'm waiting for you to type more information in order to complete this expression. Okay, and this can get a little tricky because, like I said, if you accidentally get into this situation where you're seeing the pluses instead of the greater than sign, you might go to do like another expression, like 1 + 1, and you want to execute that. But, well, in fact, we got an error here. But it can get you stuck. So if you ever leave off of parentheses like that, just push the escape key. It'll sort of like back you out, get you back to normal. You can push the up key to get your expression that you typed without retyping everything, and then push the closing parenthesis there, and then you can execute it, and then it will work. Okay. How are we doing on the questions here? Anything, TAs, any questions to bring up? Thank you for answering them in real time here. Okay, so at this point, we've just talked about using functions. Again, Google is your friend here. If there's like some concept, like I want to do hierarchical clustering, boy, that's a more advanced kind of operation that you want to do. You could type in Google R hierarchical clustering, and hopefully you should get some decent results on Google to tell you about functions that you might use to do that.
So Ryan, there's a question that
Yeah.
someone asked about the types of inputs that each function requires, and
Yes.
something, especially in proteomics field, it requires a lot of steps in order to prepare the input to just like need the function. So
Yes.
someone's asking if there are functions that can help you get that input easier.
Yes, it's a great idea. And generally speaking, the answer is yes, and the workflows are complex. I'm going to refer you to Kylie has a section on intermediate R. I think it's on Monday as part of the main institute here. Those are kinds of things that she will likely be covering in her sections, as well as, for example, the hands-on sessions on MS Stats, for example, that will go through that process. So definitely tune into those sections to get more information on those specifics. But yes, that is true in general. More complex operations require more complex inputs. And oftentimes you have a step-by-step approach where you'll take raw input data, it'll get processed to some form that then you need to have in advance before using some other complex function to process the data. So yeah, so I go to Kylie's session on Monday, and then the sessions that cover MS Stats, for example. Those will be great places to do that.
Thank you.
Okay, thanks. Okay. Okay, and by the way, sort of this section here that we're going through is sort of kind of the meat of where we're covering lots of material here. Just sort of bear with us. We're trying to build up a set of tools here that can give us some, fundamental operations to actually do some things with our data. Okay. The next section here, we're going to talk about conditional expressions here, and very simply, think of a conditional expression as just asking a yes/no question about your data. So this is something we do all the time. So some examples are, is this particular value less than 10? Is this particular piece of data equal to some value, whatever? It allows you to ask questions like that. Allows you to test your data. Okay, and here are some examples here of the basic, of the fundamental operation. So less than or equal looks like two characters together. It's the less than sign and then the equal sign that come together, no spaces between them. Same thing with greater than. We can also check for equality. In this case, we have to use the double equal sign, because I think somebody had asked a question earlier about variable assignment and asked if we can use a single equal sign instead of that arrow to assign variables. And the answer to that was yes. The single equal sign can also be used for variable assignment. So essentially that character, that symbol has already been reserved for something. The single equal sign has already been reserved for assignment. And so if we want to ask a question about whether or not two things are equal to one another, we have to use the double equal sign. Okay, it's just a way of differentiating that from the assignment operator. There's also a not equal sign here. This is a little funny. It's an exclamation point followed by an equal sign. Sometimes this exclamation point is known as a bang, but it's what you get when it's the thing above the one number on your keyboard. So, shift 1 gives you the exclamation point, and that asks if something is not equal. So we're going to have examples of conditional expressions. We're going to see those in a minute. But remember, these are asking a conditional expression asks a yes/no question. Okay, so the answer to a conditional expression should essentially be yes or no. Or actually, in the language of R, we're going to give back a true, which is a yes answer, or a false. So was this expression true or was it false? Those things return using, these are logical data types. These are different than numbers. Okay, these are not numbers. These are true and false, meaning yes and no. And in R, very important, we have to be careful with the syntax. You have to use all capital letters. So all capital TRUE and all capital FALSE. Okay, don't put lowercase because that's not the same. Don't mix cases. So don't put a capital T and the rest lowercase, and don't mix cases up. Those aren't valid. True and false have to be all capitals. So just remember that. I mentioned that because in other languages, that's not the case. You can use lowercase versions of that, and they're not the same. R requires that you have all uppercase values for those. So let's take a look at making some conditional expressions here. let's make some variables. Let's get some variables set up so we can actually do some things with it. So let's make a single variable and assign a single value to it. And let's also make a vector here. So hopefully this syntax is looking familiar for you. Now with myval, we can ask the question, is myval greater than 100? The answer to that should be true, because in fact, myval has been assigned a value of 123. So yes, myval is greater than 100. We can ask the question, is myval equal to 122? Remember, we had used the double equal sign. Okay, if you were to use a single equal sign, it still would have been a valid R expression, but what you would have done is you would have reassigned the value of myval to have 122, which is not the intent here. So you have to be a little careful there. That one can be a little tricky. So you have to just be careful. If you're asking a question about whether these two things are equal, you have to use the double equal sign. And the answer to this is false, because myval is 123. Let's see what happens if we use a vector on a conditional expression. Is myvec greater than 20? Let's try to decode what that means. What does it mean for a vector to be greater than 20? R asks this question over and over for each element in the vector. So it asks the question, is 30 greater than 20? And the answer is yes, true. Then it asks the question, is 40 greater than 20? The answer is yes, so we get a true for the second thing. Is 10 greater than 20? Nope, it's not, so that's a false. Let's look at this last one. 20 is not greater than 20. 20 is greater than or equal to 20, but not greater than, so we also get a false there. So if you ask a conditional expression on a vector, the number of outputs that you get are going to be equal to the number of inputs that you have in the vector. Okay, so hopefully that makes sense. Essentially, we're just asking the same question over and over for each element in the vector. Usually, or oftentimes, you want to save the results of the conditional expression. So there's no reason you can just take an expression like this thing and just assign it to a new variable, variable greater than 20. It will give back, in this case, this vector, true, true, false, true, false. Okay, really important. It's not giving us back the items in the vector that are greater than 20. Okay, that would be a different thing that we'll take a look at. It gives back the answer to this particular question asked on each element in the vector. Does that make sense? So we get back, this variable is going to have all of these true, false values, not the values of the vector that satisfied that condition. Okay, that might be a little tricky to think about and understand, but I'd say do some practice here and hopefully that will make more sense. Okay, so we're back to practice time here. So in the console, I want you to go ahead and make this value in this vector. And I want you to just practice executing some of these coding expressions and looking at the output. You don't need to take too much time here. Should hopefully be fairly quick to do, but I just want you to do that. And in particular, I want you to try this case here where you using the double equal sign to ask a question to do a conditional expression versus the single equal sign, and just get used to what would happen if you were to do both of those expressions that look very similar. Okay, so let's take a few minutes here to practice executing some of these conditional expressions here. Take your pick. I just want to have you have some practice executing these expressions. Okay, good question. Can we have an empty cell in a vector? That's actually a great question. It kind of speaks to the idea of missing values, which occur in real data all the time. And the answer to that is yes. Okay, it looks like one of the TAs is going to answer that, or maybe I'll answer that, but it definitely is possible. We're not going into this now, but this is an important part of the R ecosystem. R has an NA value here that refers to essentially a not available. It can be stand in for a missing value. So the answer is yes. This is a little more advanced and we're not covering the details, but we could make a vector like this, myvec 1, 2, 3, and then we stick an NA there and then have a 5 there. So if we type myvec here, you'll see that we have this sort of this placeholder for a missing value here. Let's do a conditional expression on this. My vector greater than 2. Let's look at what it does for this. It asks the question on all these elements, but it also asks on NA. This is something that can't answer. NA is like a missing value. Is NA greater than 2? Well, we can't answer that question. There's not an answer to that. So interestingly, it filled in that little missing place with an NA there because it couldn't answer that question. So generally speaking, use NAs. NAs can be used to essentially represent missing values in your data. There's a question about when you change my var from 123 to 122. Well, let's cover that. We'll cover that. Okay, so Susanna, we'll take a look at that in real time here. Okay, let's give maybe 30 more seconds. And thank you everybody for sticking through this. This is a lot of material. Again, this is the sort of the most sort of intensive part of going through the different syntax and examples here. But again, I would say each one of these little pieces that we're learning here allow you to sort of build up essential tool set to start doing some things with data. Okay. So let me go to Rstudio. Let's get a single value, my val. Let's get our vector. Okay, we have these two variables. If we print out my val, we can see it's 123. And if we can print out my vec, we can see it's this vector of values. Let's just do something. Ask an additional expression. My vec double equal sign. Does my vec equal 40? Okay. Again, whenever you do this on a vector, it's going to ask this question over and over again for each element in the vector. And in fact, the second element is in fact equal to 40, and hence we got a true there as expected, whereas we got false for everything else. Let's do this particular example where we had, so was my val equal to 122? The answer is false. Let's now, so this is maybe speaking to the question about why didn't it update? Well, first of all, again, this is not assignment. This is a conditional expression. However, if we were to take off, and sometimes you might do this by mistake, but if we were to take off one of the equal signs and we hit return, what do we think is going to happen? We're actually going to modify the value of my val. Okay, so now if we type my val, it now doesn't equal 123 anymore. It equals 122. So now, whereas previously when we ran this expression, the answer was false. Now, if we were to rerun the expression with 2 equal sign, the answer should get true, should become true. Okay, and so going back to that question, the order in which the code is executed is really important. Okay, so I'm guessing if you were trying to test this equality, you have to make sure that you change the value first before you ask a question about it. Otherwise, it's going to refer to the old value, and you won't get the expected results. And you can follow up probably with the TAs, maybe with some specific examples if that's still a question. Okay. Let me just do this last one here. Saving to a variable. We just combined, different ideas that we've gone over. So we wrote the conditional expression. We used the assignment operator, and we assign that to a variable name. And if we print this out, GT20, again, it did not give us the values in the vector that were greater than 20. That's not what this did. This gave us the answers to this question that we asked about the vector. And so we got true, false values. Equal, the number of these things are equal to the number of values that were in our original vector. To get that other question about how can we get the values in the vector that are greater than 20, we're going to talk about that in the next section here. Okay, great. Looks like our questions are doing well. Thank you, TAs, for the help there. Okay. any other questions about these conditional expressions? Okay, for time, let's continue moving forward. Now we're going to kind of hopefully bring all these things together to start doing some different things about vectors here. So the next and sort of the last section here of this syntax essentials is about subsetting vectors. And the idea is useful in the context of, this happens all the time in data analysis. You have a bunch of values and you want to get specific values or exclude specific values. So for example, let's say you're running a proteomics experiment and you're trying to determine what peptides or proteins are present in your data. A lot of times you use a false discovery rate calculation in order to find the ones that are likely to have occurred and not spurious hits. And you might want to filter your data on say a p-value or a false discovery rate value. That is an example of subsetting your data. You want to subset your data to peptides that say have a false discovery rate of less than 1%, for example. So that's a use case of where you might want to subset your data. For vectors in R, we're going to be using a subset operator, and we're going to use these square brackets in order to accomplish that. And we'll see examples here, but just note that we're using square brackets here, not the curved parentheses that we use for functions. We're going to use the square brackets to do the subsetting. And there's a couple ways we can do it. We can subset by their integer values in the vector. We can use conditional expressions like these logical vectors that we've just been working with. Or we can get values by their name, but we're not going to cover that there. That's a little more complex. And also as a side note, if anybody has any additional experience with other programming languages, if we count the integer location of a value inside of a vector, R starts counting at 1, the number 1. So the first element in the vector is number 1, starts with the number 1. That seems completely reasonable, right? The first thing is number 1. But interestingly, in most other programming languages, they start counting at 0. So the first element of a vector would be indexed with the value 0. Okay, so that's a little interesting. R is an oddball here in that it uses 1, but just want to make sure you understand that. Okay, let's look at some specific examples here on subsetting vectors. Okay, so again, we're setting up a vector here. We're using the square brackets now, okay? Really important, not the curved brackets that we use for function names. We're using square brackets to say, hey, we want to get a piece of this particular vector, okay? And if we use a integer number, this says get the first element of the vector, which is the number 30. So if you execute this line of code, you should get 30 out. If you use the number 5, we should get the last element out, and that should give us 20. Let's combine some concepts that we've already visited previously. There's no reason we can't put a vector inside of the square bracket. So that says, let's take a vector of integers to get the first, third, and fifth elements of this particular vector. And so that got the 3, the 10, and the 20. Okay. Okay, so that's about indexing vectors by position. Okay. There's no reason why we can't also ask questions like conditional expressions about subsetting vectors. So let's revisit a conditional expression about, tell me the values in my vector, tell me which values in my vector are greater than 20. Okay, this is a conditional expression. We just covered this. And again, this conditional expression is going to be asked for each element in the vector. So is 30 greater than 20? Is 40 greater than 20? And so on. And we get this vector out of true and false values. Okay, this next step is a little tricky, but hopefully it makes sense if we just build upon what we've learned so far. We can take our vector and we can index it now using this conditional expression. So we take this conditional expression and just dump it right inside these square brackets. Okay, and then this expression gives us all of the values that are greater than 20. Okay, so a little complex there. We had to use this conditional expression to in order to generate this list of true false values. And then this true false values are used to extract out the things where the answer is true. Okay, essentially giving us the elements in our vector that are greater than 20. This is definitely more complex syntax, but if you sort of break it down piece by piece, hopefully it makes sense about what it's doing. Okay, so I think the last practice time for this intensive section here, like we did before, I want you to please go back into the console and run some of these examples from the previous slide here. Go ahead and copy and paste this vector here and play around with some of these indexing operations. Maybe try changing this conditional expression to something else and see how that affects the results. So let's take a few minutes to go and try practicing on some of those items. Okay, there was a question about the space between true and false is different. Let's see, maybe you can clarify that, Ian. Are you referring to maybe the output here? Not entirely sure, but okay, the output, thanks. So R tries to make things look pretty, and I put pretty in quotes. So when it prints things out, it tries to line things up when it can. It tries to, like I said, just make it look a little bit prettier. And so it will insert kind of spaces and on the fly to just make the output there. So note that the printing the output, just like, again, this bracket one bracket is actually not a part of the result. It's just how R is printing that out. These spaces here really don't kind of exist. They're just there to separate the values. So yeah, like right here, there's 2 spaces instead of 1 space. That's just because R decided that that looks prettier than 1 space. But again, there's no consequence on the actual thing that comes out. It's just for visual representation. So I'm going to get set up here for some of our examples. Okay, so my vec here, we have this variable we can work with. For time, maybe I'll push forward and we can look at some of these examples live. So my vec here, again, we can print it out by typing it. Do you remember how to get the number of elements in the vector? We can use the length function, for example. So just some recap on that. Okay, so let's take my vector, my vec. Square brackets. Okay, remember length was a function, so we use curved brackets. If we want to subset the vector, we have to use square brackets. These are different things here. Again, we can put any kind of number here. Let's put 4 in there. We got the 4th element. Let's try something here. Let's put 10. Okay, let's see what happens. Remember, our vector only has 5 elements, and we've asked for the 10th element, which doesn't exist. Let's see what happens. So it was interesting. It gave us a result. It actually didn't supply an error here. It actually gave us a result. It's an NA. Essentially, a 10th value is not available for this vector. Okay, that can be a little tricky. So just be careful when you index vectors, because you may have expected an error to pop out, but it didn't. So it's just when you index vectors, it's useful to be careful with that. Let's take my vec and do 1, 2, and 3. Again, this is essentially taking a vector and indexing it by another vector by positioning it. And this is going to give us the 1st, 2nd, and 3rd elements of the vector. On the conditional expressions, let's do the my vec. Let's see, my vec less than 20, or let's do greater than 20 for fun. Okay, there's no reason like I said, we can't store that in a variable. So let's do that. So GT20 is the results of this comparison, my vector greater than 20. Then we can index that. by typing the name of the vector and then this new variable, GT20. Okay, remember GT20 is essentially another way to write that expression and contains these values. So when we do that, this only gives us the elements in the vector that are greater than 20. Like in the example, you could have written this all out like this, myvec, and then rewrite this conditional expression where we have to retype myvec greater than 20. It gives us the same results, or we could also store those results as a variable and just use that. Let's put the greater than or equal to sign there. That allowed us to pick up the 20, okay, because we used greater than or equal to. We also use not equal to 20, and will give us everything excluding that 20, that value of 20. Okay, all right. So again, some relatively more complex syntax, but it sort of builds upon all the pieces that we've sort of been building up to in our data. Okay. So we went through our practice. Okay, so we went through the sort of like the big portion of learning some basic R fundamentals and syntax here about actually sort of doing work with data here. Just a quick recap here. So coding syntax, again, those are the rules that dictate whether or not your code is valid. And in the beginning, you're going to be making probably lots of syntax errors. Just hang in there. And like I said, you'll get better with practice. And we covered 4 main topics here in this big section here. We talked about how we can assign variables. We talked about vectors and how we can work with them, how we can do math with them. We talked about conditional expressions as a way of asking questions about your data. You know, give me all of the data points from this particular protein, or give me all of the data points that had valid experimental runs. Those are questions you can ask about your data, and you use conditional expressions to ask those kinds of questions. Then we combined essentially like all of these ideas and topics here to cover this important topic about subsetting vectors, sort of processing our data, manipulating our data to get specific subsets that we're interested in. And in particular, that's really powerful using these conditional expressions here. Okay, all right, so it's about 10:30 Pacific time here. We're going to go to, we're going to wrap up here in about 45 minutes here. Let's take a quick 5-minute break. I know that we just covered lots of topics here. Go ahead and you know, you take a bio break or get some coffee, please do that. If you'd like to stick around, please feel free to ask questions and we can do that. Okay, let's see here. There was a question. That's great. There was a question about working with some input data here. We're not quite there to talk about working with data frames here. So let's save that question to when we work with data frames. Okay, a question here. So there was a question about sort of data types here. And there was a question about why, if we use this colon notation that I talked about previously, about sort of the type of it was a little bit different. So this colon notation, if we execute this here, if we looked here, it said it was an integer. But if we actually type that as 1 and 2 very explicitly, not using the colon notation, that it actually says it's a number, numeric. Okay, so that's a great question. This is about data types here. Sort of there is a difference between a numeric value that could have floating point representation versus an integer. For many instances, it's not going to matter too much about those things, but when you want to be very careful about comparing integers versus floating point numbers, you will want to use integers there. And this is more complex, but you can make an explicit integer with these values by adding the L character after these things. And if we execute that, you can see that the type has changed to integer. This is a way of very explicitly saying that this is a, essentially, I think that's L is for long. This is a long integer. So it's a way of specifying an integer in the R code. And if you don't specify the L's, these 1s and 2s will actually be considered numeric values have the potential to be floating point numbers as opposed to integers. Okay, so just a more complex distinction, but can be useful and important to know in the future. Okay, there was a question about, is there a possibility to put all of the commands in the same syntax? Let's see, I'm trying to think. Can you clarify on that a little bit? In the meantime, there's a question about some free courses to learn R. Yes, I'm going to highlight lots of free classes at the end. I'll bring that up at the end of today as well to provide you some links. But the short of it is, if you go to the day 2 PDF that I've provided, if you look at the end, there are some resources for free books, recommended books, and websites and places you can go for that. So take a look at the end of the PDF for day 2. Okay. I myself, I'm going to take a short little break. So we will reconvene in about a minute or two. And we'll see you in just a minute. All right, everybody, welcome back. We're going to get in here, and we're going to wrap up here in about the next 45 minutes here. Let me put a poll here. Let's see if people are back. And thank you for sticking through this. Again, we just covered a lot of material. The idea is sort of get the fundamental building blocks. Even if everything didn't make complete sense, we have some exercises that I'm going to point you to at the end, where you can practice these ideas and concepts with some mass spec motivated data. And then we can review those answers tomorrow at our next session in the morning or afternoon, depending upon where you are. Okay, I'll give it about one more minute here. Then we'll get back into it. Okay. All right. So in the interest of time, and I want to get to some fundamentals of working with tabular data. There's a section here, reading data files into R. This was just going to be a quick section here, just giving you some essential syntax to it. Let me bring it up. here. I'm just going to cover this really quickly, and then you can refer to it in more detail. But the gist of it is that if you want to do our data analysis, you obviously need to be able to get your data into R. And there's lots of functions that can help you do that, depending upon the kind of data file that you have. From more simple data files like CSV files to more complex ones like complex mass spec formats like MZML files, for example. And there are usually functions, sometimes come from different packages that exist that allow you to read these kinds of data files into R. We're going to focus simply on reading CSV files. These are comma separated value files that represent data tables. One of the most easy things to work with, and actually lots of data is represented in CSV format, so it's a very common format to use. I have some code here in our examples that we're going to be using, but the first thing we're going to do is we're going to use load a particular package known as the tidyverse package. We're going to talk more about that tomorrow, but this provides a particular set of functions from another package called readr that allows us to read CSV files using this function, read_CSV. And essentially what you do is, again, if you make an RStudio project and you have a file called example.csv sitting inside of that directory structure, you can call this function read_CSV, and then you can assign that to a variable, and then you have a data table that you can work with. Okay, so that's the high level idea here. In our examples, this code will actually just be sort of copy and pasting this code in order to do some work here. So we'll see how that works. There's some other details I talk about if you have a more complex directory structure that you just need to make sure that you reference the data file appropriately. Again, please just refer to the slides for these things. Hopefully it's relatively straightforward, or at least you can practice with it. You have to be careful about the formats of CSV files. If the CSV files aren't formatted correctly, and this happens sometimes, R will have a hard time reading it, or it will give you an error or give you unexpected results. So when you read a CSV file in, just make sure you are on the lookout for any errors or warnings that may have popped up that said R had some kind of problem. We're not going to go into details of exactly how to necessarily troubleshoot those problems, because those can be very complex sometimes or difficult to troubleshoot, but just be aware of that for the time being. Okay, so again, that's in the slides here. You can refer to that if you want some more details. But now I want to switch over to sort of the last main topic of the day here, and that's about working with data tables. This is where things start to get a little more interesting, that most of the data that we work with in real life are often tabular sets of data. Sorry, I should ask, are there any questions previously? Okay, this is great. Sorry, before we get into working with data tables, I want to make sure everybody is up to speed. If you're using Rstudio Cloud, I've already installed this tidyverse package for you. And if you type library tidyverse, well, okay, Rstudio Cloud, this will work here. Let me resume this as this is resuming. In the instructions on that May Institute document with the pre-set up instructions, I have instructions there. But if you don't have the tidyverse package installed, go ahead and do this right now. It might take a little while, but in Rstudio, if you haven't done this already, I want you to go up to Tools and click Install Packages. And then in this window here, type tidyverse. Spell it right, V-E-R-S-E, tidyverse. It will kind of try to complete it for you. And then click Install. Okay. This is going to go and install a bunch of packages associated with the tidyverse. It might take a minute or two, so go ahead and just kick that off. And then when we get to these examples here coming up, you should be able to have it. If you're using Rstudio Cloud, it should all be ready to use. So let me go back to my Rstudio Cloud instance here. So this is an Rstudio Cloud environment. We type library tidyverse. That will load the tidyverse library. Don't worry about these warning messages here. It's just telling you that it loaded the package. And note, we haven't talked about specifically what packages are or their details, but just note that we are loading essentially an external package that gives us access to additional functions like the read functions that we just talked about. Okay, so that's the main thing to know. Okay. Let's go back to working with data frames here. Okay, in R, the name of these data structures are known as data frames. In the context of the tidyverse, they're also known as tibbles. Sorry, funny name. It's just what they decided to do. But if you see the name of tibble, just think of that as a tabular data frame, a tabular data structure. And so, all right, so that was nomenclature. Note, I don't have to tell you, tabular data is everywhere. So we work with data in Excel. That is a tabular data by its very format. It involves rows and columns here. CSV files are a way to represent tabular data. In journal articles, we have tables. So tables are everywhere. Tabular data is everywhere. It's important to be able to know how to work with it because it's so common. Important thing about tables, perhaps it's no surprise, but just reiterate that tables arrange data in a sort of a two-dimensional structure where you have rows and columns, and then particular values get stored in cells in the table. Okay, so nothing too complex here, but the idea of rows and columns and cells are going to be important when we talk about manipulating and working with this data in R. Like I mentioned, when the data frame, that is a specific term that R uses to store tabular data. Okay, so if, for example, if you want to learn about tabular data in R, you'd want to use, like in Google, you'd want to search for the term data frame. That's something that R uses to refer to that. I very briefly went over the idea that we can read, for example, CSV functions into R using the read _ CSV function that's available through the tidyverse package. The thing that this returns to us that we get back out after the read is usually a data frame. Okay, so we don't get a vector back, we don't get a single number back, we get a data table back out. So that's important to know. You might also see, just if you see some code here, sometimes the data frame has referred to as a data.frame. You'll see this in code sometimes. That's how R refers to a data frame and can actually be used as a function to create data frames, but that's not too important to know. I just want to point this out in case you see this in other code that you review, that this is just referring to a data frame. Okay, if you read in a data frame, and we're going to do this shortly with the tidyverse package, and then you print it out, you get a much more complex output than just sort of that listing of, say, vectors and values that we saw previously. There's actually quite a bit of information here that we can already use to start understanding our data. So this is a particular input data file that we're going to read here. And if we type it, look at what we get out. We get the names of the columns here that are popping up. Okay, sometimes the names of these columns are too long, so they truncate them. And that's what those ... dots indicate. We can also see the type of data that is stored in the column. The CHR stands for character. Just think of those as like words. So these are letters and words here that are showing up. So these are character kinds of data. This is a charge for precursor ions. Those are stored as probably would make sense to maybe store these as integers, but in this case, I actually read it in as a double, a numeric sort of potential to have floating point representation, but in this case, it's just sort of numbers 3. In this case, this is a mass over charge value. That's also a double, and also some other types. It also tells us that there were 9 more variables, 9 more columns that it didn't print out. And it tells us what their names are and what their types are. We can also see the number of rows and columns. So this particular data set has over 1 million rows and 16 columns. So just by reading the data table in and then printing it out to the console, we get actually quite a bit of information about our data already, which is really pretty cool and is a nice view of understanding our data. Just like we used functions to operate on values and vectors, we can also use functions that operate on data frames. Okay, so we can understand ideas about the data frames, about sort of their properties and so on. And here are some examples here. If we wanted to find the number of rows and columns, we can use these particular functions, nrow and ncol, or we can also use this dim function that gives us the dimensions together. We can get all the names of the columns in our data table. If we look back here in this example, this was a long name of a particular column here. And so it truncated it in the output. This is just for visual representation. But if we wanted to get the actual full name, we could use this names function. It would tell us the full names of all of the columns. As we practice data tables, we're going to use this view function to see what happens in the RStudio. We get another cool representation of this. This is another weird syntax thing that R has, but if you type the name of a data frame, put the $, and then the name of the column with no quotation marks, it will actually return all of the data in that column to you as a vector. Okay, so we worked with vectors previously. We know what vectors are. This is a way to get a single column of data. So for example, all of the precursor charge values as a vector, where we would refer to the column name here, precursor charge, to get all of this data here. Okay, so let's do some practice time here. We need to get set up. I want to make sure you're set up. If you're using Rstudio Cloud, you're already set up and ready to go. You could execute these lines here, and the code should work. If you're working on your laptop or on your own local computer, make sure you've installed the tidyverse package like I just went over. And then make sure that you copy into your test project, your RStudio project that we made previously and where you've been working with the experiments, the examples, copy that exercise data to that same directory, okay? Again, those are on the GitHub site. Maybe the TAs can link to that GitHub site if you haven't gotten that data here. But again, if you go to the GitHub site, you want to come to the data folder, the exercises data.zip file, and download it, okay? And then unzip it, okay? And then we made this test project before. Just make sure that you have that test project open and that you copy, actually I can get rid of this, make sure you have this test project open and that you copy these two data files here that you downloaded, copy that into your test folder, okay, so that they're present. I'll do that as well. Okay. So let's see what happens when we come here. So let's take these two lines of code. Let me get you started here. Again, if you're in Rstudio Cloud, you can just execute these right off the bat. Let me go to RStudio here, and let me execute this first. Sorry, I should probably do this line by line. Okay, so first, again, we need to load the library so that we have the ability to read a function in R. So we're going to do library tidyverse and execute that. Then we're going to read our data file. We very quickly covered this in the previous section, but we can just copy and paste this code. Whoops. Okay, and read this data file in. Okay. All right. Now, once you have this variable called dat, go ahead and work through some of these exercises. So for example, to get you started, type the name of the variable here. So dat is what we called it. If we type the dat, we get this view of the table like we had before. Then I want you to come back to some of these functions here. And just like we use these functions on vectors, I want you to use these functions. Now you're going to supply the data frame input and look at some of the outputs there. Okay. So let's take just a minute or two here because we're getting short on time and try some of that. All right, I will go ahead with some examples here, maybe as you're working in the background, so we can keep going here. So we have our data frame here. We know that it has 12 rows and 3 columns here because the output told us here at the top. But we could also use these functions, n row. We use the curly parentheses because we're calling a function called n row, and we can put the data frame name there and hit return. And it will tell us that it has 12 rows. So that agrees with the output here. So that's nice. I'll say n call the number of columns on the data frame and tells us we have 3. Okay, that's nice. Let's type names on the data frame. That will give us all of the names of our columns here. Okay, this is useful, for example, if you want to refer to a specific bit of data in your data frame. Let's use this odd syntax where we type the name of the variable for our data frame. Then we type the $. Rstudio is nice because it will actually pop up a little completion window here that allows us to actually select without typing all of the names of the columns that are available to us. There's no reason we could just type this out explicitly, but we could also, after we type the $, use our arrow keys to select the name of the column and press enter, and it will fill that in for us. That's nice, so you don't have to, worry about making typos. And let's execute that. Okay, so this printed out a vector, okay, of the conditions, and essentially took all this data as a condition here to essentially get that data to us as a vector that we could then work on. And if you probably can think about sort of the topics we covered previously, you can maybe start to imagine how we can use some of the previous ideas about working with vectors and conditional expressions where we could start doing some operations on this particular data table here. Okay, and we're going to cover that in just a minute. Let's see, let's go here. Okay, so so just to summarize, one of the ideas here was let's get all the data from the bioreplicate values here. So let's store that. Let's call this biorep as our variable name, and let's grab that data using our $sign operator to get the bioreplicate values and store that to the variable. Okay, now we have a vector here. Biorep is now a vector. It's not a data table, it's a vector now. Then we can use our functions that we saw previously, like max, to get the maximum bioreplicate value. Okay, so we're now kind of doing some data analysis on these data tables using all those pieces that we built up to in the previous section. Okay, let's check in on some Q&A here. Okay, somebody was getting some, okay, one thing about Rstudio Cloud here, somebody had asked about that. I already have a workspace all set up for Rstudio Cloud for you that has all the files. You don't have to transfer anything. You don't have to install anything. If you go to the May Institute page, okay, let me go back here. Go to the May Institute page and click on the documents for day 1 here. Come down and follow this link here for the Rstudio Cloud link. If you do this, go to that link and you'll be able to go to a workspace and get exercises where all this stuff will be ready to for you to work on. So you don't have to copy anything or anything like that. You will go to an exercise page that looks like this, where you can start working on the exercises by clicking the link there. Okay, and the data files are there. There is an error. Somebody's getting an error when they're loading packages. Raja, we're going to have to maybe troubleshoot this. I apologize. These technical issues do pop up sometimes. If anybody is having issues loading packages, unfortunately, these things pop up, and we can troubleshoot at the end of the course. It's going to be a little difficult to do that live here. Okay. If you're using Rstudio for your own project, so we talked about using Rstudio projects, and to set that up, let me briefly review that because that's going to be important. From Rstudio, this is what you're going to want to do to get set up. Make sure you go to File, New Project. then do a new directory and a new project. Put it somewhere like on your desktop, I would suggest. And let's call this test2 and create the project. When you do that, then wherever the directory is, I have lots of folders here, but in that test2 project directory that it creates, you're going to want to copy those data files that you downloaded into that directory. Once you do that, and you have the Rstudio project active, you will be able to execute those the read commands there. And I'd say reach out to the TAs maybe if you have more technical support issues, and we can cover that at the end as well. Okay, all right. Okay, so let's now go back to this. So we were in Rstudio here, and we loaded the data up. Let me get that back up here. Grab this data file here. To the library, tidyverse to load the package. Then we use the data file to read the data file in. Okay, and we did some operations on there. Okay, let's keep going here, and we're sort of getting to sort of wrapping up here. Remember that we talked about subsetting vectors, but also subsetting data frames are really important part of working with data. Again, like we want to filter values out depending upon their p-value, or we want to filter data to a particular subject number or an ID number, or maybe a particular experiment. This falls under the concept of subsetting data frames. We already saw in the previous example that we can subset to a single column using this $sign operator. Okay, so we already did that. But also, just like vectors, where we use these square brackets to subset, we can also use square brackets to subset data frames as well. But remember, data frames have rows and columns. So it's slightly more complex in that we have to subset based upon both row selections and column selections. We can't just put a single expression here like we did for vectors. We actually have to supply two that refer to the rows and columns that we want to subset. And we separate those with a comma. Okay, and so let me give you an example of that here. So again, let's say we have a data frame stored in a variable called mydf. We have to specify a row selection, and that could be a vector of integers, likely supplied for the vector subsetting operations, or it can be a conditional expression like we did for vectors. Those are, I think, sort of the two main examples. On the column selection, we can also use numbers to refer to columns by their number, or we can also use the names of the columns here. Finally, we can also use true or false values, but we really won't get into that. It probably makes the most sense to show some examples here. Yeah, let me show some examples here. So let's take a look at, in the interest of time, I'm going to run through these examples here, specifically in Rstudio here. Okay, so we have our data frame here. Let's say we want to subset this to a single column. We've already done that, where we can use the name of the variable and any of the column names here. Again, Rstudio will complete that for us, so we can just push return. This gives us all the values of the data in the run column. Let's now use the square bracket subsetting operations, where we have both a row selection and a column selection. Let's do this particular idea, where we have a vector of the, we use the C command for our vector, and we get the first two rows and maybe the first two columns. Okay, so again, this is our row selection. This is our column selection. This will give us a data frame, a smaller data frame that has just the first two rows and the first two columns of our table. Okay, so, and we can manipulate that as we like. Sometimes if we just want to get all the rows or all of the columns, we can just leave the specification blank. You still have to supply a comma, but you just don't specify anything after the comma. And if you hit return, this will return all of the columns that are available. We can do the same thing by getting rid of the row specification and hit return, that will return only the first 2 columns, but all of the rows. Right, so those are some basic things. So, those are potentially useful, but I think it gets really useful when you have conditional expressions. So for example, let's take our data table here. Let's say we only want the data associated with condition 2. So what we can do here is write a conditional expression. Let's do that first, and let's save that as a variable. So let's call this row cell. And we're going to write our conditional expression, that $condition. We'll use our double equal sign because we want to ask the question, and then we put in quotation marks, condition 2, and we can copy and paste this. Okay, so this is going to ask the question in this data frame, which values are represented as condition 2. As we saw before, this is going to return a vector of true false values for each row here where this was true, okay? Then if we take our data frame and supply this row selection, and we put a comma with nothing after that, meaning we want all of the columns, that now just did a subset of our data frame to only the rows where the condition was equal to 2.
Ryan, someone asked if it's possible to slow down. So maybe just 1-2 minutes.
Yes, great. Yeah, I'm sorry, I'm sort of rushing a bit here at the end here. Apologies there. So the main topic we're covering here has to do with subsetting the data tables here. And so just like when we had vectors and we used the square brackets to subset. So let's take a vector here. So this vector has 3 values, and we can type the my vector and then use the square brackets to subset and say put 2 in there to get the second value. We can do the same thing as well using the square brackets. And so with our data frame here, we just have to make sure we supply both a filtering criteria that corresponds to both the rows and the columns. Okay, so that's sort of the main concept. Then we can use sort of the other ideas of conditional expressions that we learned about in the previous sections in order to do those kinds of cases. So let me give you another example here to make it more concrete. So let's get another case where we only want the rows that are equal to where the bioreplicate value is greater than 2. So again, we're going to type our data frame. We're going to put the square bracket. We're then going to type a conditional expression. In this case, it's our dat $bioreplicate value. This is going to give us all of the values in the bioreplicate column here. And we want those values to be greater than 2. Okay, so this is a conditional expression that we sort of went over previously. So that's going to tell us about the rows that we want. Now we have to say about the columns that we want. So we have to put the comma there to say that we are now going to talk about the columns we want. Since we want all of the columns, we're just going to leave that blank there. So no specification, and that will give us, like we saw, the table where all of the bioreplicate values are now greater than 2. Okay. So that's the idea of subsetting, data subsetting. Let me now, essentially we have a bunch of pieces here that we can then put together to look at some examples. And what I'm going to do is this will sort of be maybe a homework assignment that you can work on today to work through some of the material that we've gone through. And I will bring those up in just a second, but maybe some of that was kind of fast. Are there any additional questions about subsetting data frames using the row and column selections here? And again, some of this is going to be complex, obviously, particularly if you're new to R. So what I would recommend is go through some of these examples, maybe piece them out, work them sort of step by step, and sort of try to work the pieces and see if you can understand what's going on. We're also having another session tomorrow. So as you go through some examples, here, please write down your questions. And the first thing we'll do tomorrow at the session is go through some of those questions after you've had a chance to practice some of these ideas. Okay. So now we're getting sort of, we have what, about 10 minutes left here. Let me point you to some exercises here that I think would be useful to work through that cover the main ideas that we worked through today. If you go to the GitHub repository and you go to exercises here, there are two exercises here marked as day 1, and they cover, let me just bring those up in R here. I think I have these in my directory. Bear with me one second, where I go to my projects. You can down, and actually, let me give you a quick tip as well. Maybe I'll just do this to show you. At the GitHub repository, if you go to the main link here, you can download as a zip file. So let me just do that. This will download the whole repository as a zip file. It's a little big, so it might take a little bit of time, but it will download, and then you can have access to all the files there. Let me open this up. Okay, so in this folder, you can download and take a look at it. All the lecture slides are there. The data are here and the exercises are here. Let's take a look at this, the day 1 exercises. Actually, we'll just open this up in Rstudio. Okay, so let me make this a little bit bigger. So I'd like you to, afterwards, maybe some homework for today, I'd like you to go through and try to work through some of these examples here that cover the things that we worked with. This isn't an R script that you can bring up. And the idea here is that you can go through and read these, the questions here. These pound signs refer to comments. Essentially, this is a way to say, R, don't do any code here. Don't execute any code here. This is just for any kinds of notes. And I put these questions here in these comment signs. So for example, in this first exercise here, I want you to create a variable that holds called gradient minutes, and it holds a 60-minute gradient. And so you would type the code here to be able to do that and work with that. And what I'd like to have you do is go through and work through these exercises here that sort of practice some of the main ideas that we talked about today, kind of motivated by some mass spectrometry related examples. Okay, so there's two of these kinds of exercise files. Let me show you the other one here. So this first one is about sort of that main chunk where we covered all those individual pieces. This second one here is about working with data frames, what we just went over, admittedly a little bit quickly, but again, try to go through these and look at the slides and see if you can sort of do some basic data analysis on these data frames. And so, for example, we're going to be subsetting some data files. We're going to find, for example, how many unique peptides are present for a particular type of protein and so on. So to motivate some of those examples. All right, so try to give these a shot if you have time today, and then write down any questions. I will go through essentially the solutions to these exercises first thing tomorrow before we start in on the main material. All right. So we're coming up here in just a few minutes here. Obviously, let me say that we covered a ton of material today. Obviously, lots of stuff here. Hopefully the slides will provide a reference for lots of these main concepts. And I think the idea is that essentially we presented a bunch of individual building block pieces that you can then begin to put together to start doing some data analysis. And in particular, we'll bring that up tomorrow, where we'll actually be doing some data analysis pipelines using a really cool R package called dplyr that allows you to do some really neat data manipulations and some actual data analysis. Let me share one more thing just before we depart here. If you go to the day 2 PDF here, if you go all the way to the end, for anybody that's curious, go to the end of these slides here. there is some resources here. So for example, there's a great learning resource on the Rstudio blog here that has all kinds of resources. I think most, if not all of them, are free. And that's a great place to start to look for additional learning resources if you want to start looking that up. There's also 2 really good books I would recommend. There's Hands-On Programming with R. This is an online book. It's completely free. The idea here is to, again, in a lot of detail, walk beginners through learning R as a programming language. Again, it's not necessarily scientifically oriented, but more about learning to work with R. It's a really great book to sort of start you from the beginning and take you step by step. For a more scientifically related book, there's this book called R for Data Science. Again, an outstanding book. I think all R users at some point should read this book. It's fairly well written. I think beginners could get through it with the examples. It's definitely going to be more advanced and assumes you have some more basic knowledge of R, but it's a great resource. And even if you can't understand it right now, it's something I'd highly recommend dipping into as you go along in your R journey. Okay, so those are some resources to cover. Great. Well, let's see. Are there any last minute questions here we want to cover before we wrap up for today?
Yeah, there's a first question which asks how to subset with a